Hello guys, welcome to the GATE 2023 detailed question and answer discussion. Yes guys, the intent of this video is to present to you all GATE 2023 electronics and communication questions along with their complete solution, so that in one go, in one video, you're able to completely analyze the paper, see what are the questions that have been asked, and also see what is their relevant proper solution. Let's get started. And before we directly start up the question, let me give you an overall summary about the GATE 2023 electronics and communication. The paper, if we compare it to the last year, it is easy to moderate, because last year we have seen a better paper in electronics, so mostly towards the moderate side the paper is. Okay, and as you all know, not only this year, every year the IIT will pick up maybe 2 or 3 subjects which will be more tricky. Okay, and rest all the subjects will be more easy to capture. So this year EDC, signal and system, and EMT questions were slightly tricky, right? And all these things, all these questions, so Sanjay Rathi sir will discuss those questions of EDC, I will discuss those questions of signals, Saket sir will discuss the questions of EMFT. So you'll understand what is that tricky nature. They are not difficult, but usually involving some good property and good concept. So if your preparation was to the fundamental and conceptual level, then you can handle those questions. MSQ this time relatively not very high, only 4 MSQs, right? NAT 16, the drastic changes, MCQs. Okay, usually now MCQs were reduced around 30-35, but this time we have seen 45 MCQs in the electronics paper. Now let us also talk about the distribution of the marks. More or less, it's not a big deviation. Okay, it is mostly the same except for 1 or 2 subjects. So control system 9 very much expected. Digital usually expected for 8 or 9, but is 7. So 1 or 2 marks variation is always expected by IITs. EDC and analog. See, don't only see EDC. EDC and analog total 17. Usually we expect 18 to 20. So that is also almost on the track. Signal and system usually expected for 9 to 10 marks, but this time it is 12 marks. Okay, and 2 or 3 really good questions that we are going to see into that. Communication is expected more than 10 marks, so it is on the 12 mark side. Analog already I discussed. Network usually as electronics is expected for at least 8 to 9 marks, but it is 6 marks. So that is slightly low. Okay, electromagnetics 11 marks. So from the past few years, electromagnetics, they are asking in good quantity, sometimes 11, sometimes 10 or 9. So it is again a very good and crucial weighted subject. Engineering mathematics, see, actually the official weightage that IIT says for mathematics is 13 marks, but here it is 11. So we can't really blame them also, because 1 or 2 questions of this engineering mathematics, okay, is like totally based, one of the question is totally based on random variable. Okay, but yeah, that requires some knowledge of communication. Okay, yeah, some depth understanding of random variable that you study in communication, not in engineering mathematics. Some question of maths gets linked with the electromagnetic course as well. Okay, so more or less it is 11. So don't you can't blame IIT ki 13 kyun nahi hai, because 1 or 2 questions can be directly linked with that. Like one question of random variable is there. Okay, we can put it in maths also, but yeah, actually it can be for electronics, it should be put in communication. That is why we have included in communication. So more or less maths weightage is on track only. Aptitude, there is no chance of discussion because it is fixed from last several years only, 2010 onwards only, it is 15 marks. So this is what is the weightage distribution. No big surprises in the weightage distribution. It is almost on track except for maybe one subject. Okay, and this is just the pie chart of the same distribution you can go through, just briefed out in that table. Okay, also guys, let me compare with the previous year and then let's start the questions. Okay, so 2023 is the year that we are talking about right now. We are here at 2023, and if we are going to make the relative analysis, as I told, control system 7, 8, sometimes it goes high as 12 as well, but on an unexpected, even if you take the average, it will be coming out somewhere around 8 to 9. Digital 7 marks. EDC, so you can look into the last 3 trends, it's almost matching up. As I told you, signals is slightly higher this year. Communication, see, it is more than 10 marks expected easily. Sometimes it can shoot up to even very high weightage like 16 marks. Okay, analog, see, consistently 10, 9, something like that is expected. Network, as I told you, 8 marks at least we expect, but this time it came up for 11. Okay, electromagnetics, yes, again, as I told you, the weightage of electromagnetics is going high this year, seeing it for 11. Okay, mathematics, I already explained you, weightage is already fixed 13 marks, but 1 or 2 question of maths for ECE especially can be linked with any other subject, and aptitude is the fix. So this is a slight comparison with the previous years as well. And now let's have a look into the detailed question discussion. Okay, so let us get started with the very first subject, that is the digital circuits. Okay, and the first question is a very simple MCQ 1 marker, very simple, expected from multiplexer. Okay, so we need to, in the circuit shown below, P and Q are the inputs. What is the logical function realized by the circuit shown below? Okay, so what is the output P? What is the output Y? Sorry. So what is the select line here? Select line is Q. So whenever the select line is 0, we will represent Q bar multiplied by I naught, and I naught is grounded, that is logic level 0. And whenever the select line is 1, we will write Q multiplied by the input I1, which is equal to P, right? So Q bar into 0 is just 0. So output is QP or PQ. So correct answer for the first question is A. Moving ahead to the next question. Okay, the second question. The synchronous sequential circuit shown below works at a clock frequency of 1 gigahertz. What is the throughput? Okay, in megabits per second, and the latency as well. Okay, so what is the clock frequency first of all given here? Now, some students had little confusions about this, so I'll give the final solution for this. This is 1 gigahertz. So what is the time period of the clock? The time period of the clock is 1 upon clock frequency, and that will become 1 upon 10 power 9. That is going to become 1 nanosecond. Okay, so what is the latency? Just like delay. Okay, so what is the delay for the circuit? Let's calculate them, and then let's come to the throughput. The throughput. Sorry. Okay. Now, latency. It's a basically shift register with the serial input given here, and this is the serial output. Okay. Now, suppose any bit you apply here, say that is the serial input, and the clock cycle is 1 nanosecond. Clock period is 1 nanosecond. Okay. So at the end of 1 nanosecond, you are going to see it here. Okay. Right. Then after next clock, this is going to be transferred here. So yet another after 1 nanosecond, you see it here. And that is total 2 nanosecond. And yet after 1 more nanosecond, you are going to see this to the final output. That is a total of 3 nanosecond. So for any particular bit, if you think, what is the total time for it to be transferred from the serial input to the serial output is a matter of 1 nanosecond. That is going to be a matter of, that is going to be a matter of 3 nanoseconds. So in short, let me mention here that latency of the circuit, okay, for any particular bit, that is 3 nanosecond. But what is the throughput? Okay, that is the, what is the information being passed in 1 second? Let us calculate that. And here the unit required is in megabits. So how many megabits per second is passed by the system? That throughput we need to calculate. Okay. Now, if you see, you may think that latency is 3 nanoseconds. Okay, so in every 3 nanoseconds, 1 bit is getting transferred. No. Remember that although it is a shift operation, but one after the other, the bits coming after each other. Suppose you applied 101. Okay, 101. After the first clock edge, after the first clock cycle, this is going to appear here. This bit 1. Okay. Right. After 2 nanosecond, it is going to be appearing here. After 3 nanoseconds, it appears here. Right. This bit 1. But after 1 nanosecond, when the bit 1 was transferred here, the 0 bit will be ready. The 0 bit will be ready to the serial input. And then yet another after 1 nanosecond. That is 1 plus 1. Okay, 2 nanoseconds. This is going to be seen here. After another 1 nanosecond, that is 3 nanoseconds, it is going to be seen here. After another 1 nanosecond, that is 4 nanosecond, it is going to be seen here. Right. Similarly, this is seen here at 3 nanosecond. This is seen here then at 4 nanosecond, and again after 1 nanosecond, that is 5 nanosecond, the last bit is also transmitted. So, of course, for the very first bit, okay, for it to be transferred to the output, it takes 3 nanosecond. For any particular bit, even this is also taking total 3 nanoseconds. Okay, but at the output, what is the frequency you are able to see? Okay, let me write it this way. Let me explain it this way. That first bit is seen at 3 nanosecond. Second bit is seen at the end of 4 nanosecond only. Third bit is seen at the end of 5 nanosecond, etc, etc, etc. So at the output side, in every 1 nanosecond, okay, neglecting the startup effect, after every 1 nanosecond, you are able to see 1 bit. You are able to see 1 bit. Let me put it this way. Okay, you are able to see 1 bit in every 1 nanosecond. Right, 1 bit in every 1 nanosecond. Okay, so I can put it like this. 1 nanosecond, 1 bit corresponds to 1 bit, right? So 1 nanosecond is 10 power minus 9. So in 1 second, how many bits you will see? In 1 second, you will be able to see how many? 10 raised to the power 9 bits. Okay, 10 power 9 is actually 1000 is multiplied by 10 power 6. Right, and what is 1000 into 10 power 6? 10 power 6 is mega. So that is basically 1000 megabits. Okay, so that is what is the throughput? What is the information passing through the system in every 1 second? It is 1000 megabits. So we have 1000 megabits per second. We have the 1000 megabits per second. Moving ahead to the next question in digital. Yeah. For the circuit shown below, the propagation delay of each NAND gate is 1 nanosecond. What is the critical path delay? What is the critical path delay? It's a NIT 1 marker, again a simple question. Okay, for the circuit shown below, propagation delay of each NAND gate is 1 nanosecond. Let's understand. Okay, so suppose now a critical path delay means the worst case delay you have to consider, assuming that both the gates are active. So what we can assume here is, suppose you applied the input as 0, because input A is 0, the input to NAND gate is 0, its output will be high. If any input is 0, irrespective of the other one, if any input is 0, output will become high for the NAND gate, right? Okay. But for the output to become high, it has to cross to the NAND gate, which has a delay of 1 nanosecond. So if this is 0, the output becomes 1. Okay, the output becomes 1. Okay, so this 1 comes up here. Okay, this 1 comes up here, right? And let's say B is also 1. Because if the B was also 0, if B was also 0, both NAND gates output can be seen after 1 nanosecond, because any input 0, output will be 1. But let's assume B1. Okay, and ऊपर से भी 1 आया, because when both the inputs for NAND gate are 1, 1, then the output is 0, but you receive this 1 after 1 nanosecond. This information will pass through NAND gate after yet another 1 nanosecond. So you are going to see, this was seen at 1 nanosecond, but you are going to see this total after 2 nanoseconds. So the critical path delay will be 2 nanosecond. Okay, for some of the input combination, the delay could be 1 nanosecond as well, but the worst case delay will be 2 nanosecond. That is a very simple answer to the question, 2 nanosecond. Previous one, let me mark out. I think I did not mark the option. 1003, option number A. We got 1000 as the throughput and latency was 3 nanosecond. That's it. Moving ahead to the next question. This was the third also done. A fourth question, 2 mark. Now, this is not perfectly, we can say, a digital question. Yeah, but it has been placed here. No problem. We'll discuss. Okay, you can keep it, network or analog, anywhere. It's a common concept. Okay, a sample and hold circuit is implemented using a resistive switch and a capacitor with a time constant of 1 microsecond. Okay, so let me first talk about this circuit. The time constant is directly mentioned. Okay. So R and C values may not be required. Okay, and the time for sampling switch to stay close to charge the capacitor adequately to a full scale voltage of 1 volt. So we need to charge the capacitor up to a level of 1 volt. Okay, with a 12-bit accuracy. Okay, first of all, what is the charging voltage for the capacitor? Okay, that we all know, it is given by VCT is equal to V in T into 1 minus e raised to the, let me simply write V in into 1 minus e raised to the power minus T by T, right? Where T is equal to RC, that is given to you as the time constant, which is 1 microsecond. Okay, the time constant has been given to you, right? And we need to charge to a full scale voltage of 1 volt. So this is also, let's take it as 1 volt. Okay, so eventually I can say that VCT is equal to V in, which is 1, V in, which is 1. So it is simply 1 minus e raised to the power minus T by tau, by the T or tau, whatever you want to call it as, and that is 1. Okay, so 1 in what? 1 in microsecond. So let us also assume that T is in microsecond. Okay, so that I can write down that the voltage is 1 minus e power minus T. Now, what is the time for the sampling switch to stay close so that the capacitor is charged to a full scale voltage of 1 with a 12-bit accuracy? Yes. So even that means what? Even if there is a deviation, okay, it should be maximum up to 12-bit. Now that means, where is that equation? Where is that equation? So we need to charge it to maximum of 1 volt, and the exact time required to charge to 1 volt is infinite time, because e power minus infinity will only become 0. Okay, but by what time it will be charged up to accuracy of 12-bit? That means, okay, that means what I require here is that the capacitor should be charged, okay, perfectly to 1 volt, but with a 12-bit accuracy, and the 12-bit accuracy is represented by 1 upon 2 power 12, as we all know, right? So it can be charged up to 1 minus 1 upon 2 raised to the power 12. This much of the error or tolerance is acceptable here, up to 12-bit accuracy. Okay, so that means 1 minus e raised to the power t is 1 minus 1 upon 2 raised to the power 12. 1 to 1 cancelled. E power minus t is 1 upon 2 power 12, or you can just take the reciprocal of both of them. So e power t will be equal to 2 power 12. So what should be the value of t? T will be equal to ln 2 power 12, which is 4096, and this will be turning up to be, just let's calculate this number, guys, quickly. ln 4096. Okay, so 8.3177 approximately. 8.3177 microsecond. The unit is microsecond, already I mentioned, correct? So 8.3177. Now up to 2 decimal places they are asking. So 8.32. 8.32. That is what we can mention. We can call this as 8.32 microsecond. Anyways, the official answer key, okay, as far as I remember, the official answer key is 8.3 to 8.4, because whenever, okay, the answers are not perfect integers or something like that, they always evaluate in a range. So don't worry. So you're given a range 8.3 to 8.4. Chalo. Okay, so even if you enter 8.31, that's not a harm to you. Let's move ahead to the next question. Okay, that is again from digital, NAT for 2 marks. In the given sequential circuit, initial states are Q1 and Q1 is 1, Q2 is equal to 0. For a clock frequency of 1 megahertz, the frequency of the signal Q2 in kilohertz is how much? The frequency of the signal Q2 in kilohertz is equal to how much? Rounded off to the nearest integer. Rounded off to the nearest integer. Let's have a look into this. A simple question based on, sequential circuit where both the flip-flops are commonly clocked. That is a synchronous counter type of design. Q1 is 1, Q0 is 0. Okay, and clock frequency is 1 megahertz. Let's come here. The frequency at Q2. The frequency at Q2, because the frequency at Q2, considering it to be MSB, can be written as how much? The frequency division concept, that can be 1 upon n, the clock frequency, right? What is the value of n? That is what we need to figure out. Okay. Now, several students had confusions and they also, claimed this question. The question was challenged. The challenge was accepted also. The convention was regarding this notation. Okay. Q1 bar and bubble. So, does it mean only Q1? And the challenge was, fortunately accepted also, okay, because, people found this some reference in the NPTEL videos, and that is why IIT had to accept this. But although if you read some good standard textbook, okay, you will understand that whether it is Q bar or whether it is bubble, both of them means, the bubble means low representation. As nahi ki bar and bubble will cancel each other. And you can think like that also, na? If bar and bubble cancel each other, so that is Q1. So Q1 is already available. A flip-flop will have 2 outputs. One is the true output, one is the complement output. There is no point, both the outputs are Q and Q. But fortunately, the challenge is accepted. Okay, no problem in that. But actually, this is Q1 bar only, right? This must be taken as Q1 bar only. So based on that, now let me start solving. Okay, let me write down both the values Q2 and Q1 here. Assuming initially Q1 is 1 and Q2 is 0. Q2 is 0, Q1 is 1. That is what is the data given to me. Okay, Q2 is 0. Now please listen to me. Okay, what is the equation for Q2 plus? Okay, what is the equation for Q2 plus? For any D flip-flop, Q plus is equal to D. So Q2 plus is equal to D2, right? But where is D2 coming from? D2 is coming from Q1 bar. Okay, next, what is the equation for Q1 plus? That is D1. But what is D1? D1 is coming from Q2. That means, listen, whatever is the current value of Q2 will go to the next state of Q1. Whatever is the current value of Q2 will go to the next state of Q1. Okay, so Q1 is going to become 0. And then Q2 plus is equal to Q1 bar. That means whatever is the current value of Q1, its complement will go to Q2. So what is one complement? 0. Now just keep, okay, so just slide the Q2 to Q1 and iska complement here likhte jana hai, right? So 0 complement 1, and then this is also 0 this 0 to be written normally, I'm sorry, and then this 0 complement is 1. Then 1 slide to the right and 0 complement 1. Again 1 slide to the right and this 1 complement will be 0. Okay, next is what? Again 0 slide forward and 1 complement is 0. 1 complement is 0. Okay, but you can feel from here only that repetition actually occurred. We started with 0, 1 and we came back to 0, 1, and that is why next state is 0, 0. Right. So how many number of states actually? 0, 1, 0, 0, 1, 0, 1, 1. Then this is the repetition. Okay, so these are the total distinct or unique number of steps. We have mod 4 counter. This is known as the modulus number. Okay, so what is going to be the frequency of Q2? It is going to be 1 upon 4, the clock frequency, which is given to you as 1 megahertz. 1 megahertz. So this is going to be 1 by 4 of, answer is required in kilohertz. So 1 megahertz is 1000 kilohertz. So the answer is 250. So the answer is 250 kilohertz. Answer is 250 kilohertz. Okay. Answer is 250 kilohertz. Now official answer. 250 was the original answer given by IIT, and there was one more answer added, that was 500. Both were taken as correct. Okay, so question was not changed. It was not marks to all. There was no cancellation of question, yeah, marks to all thing. They have given both the answer based on the convention. If you take Q1, right? If you take Q1, so if you take that consideration also, what is going to happen? Let me explain you that. कि अगर इसको Q1 ले लिया, right? Then what is going to happen? Okay, if you take it to be Q1, right? So if you take Q2 plus, which is equal to D2, but D2 equal to Q1 based on bubble bar cancelled. This is based on what? Based on bubble bar, but usually ऐसा होता नहीं है, okay? Used based on bubble bar cancels. Okay, so if that is the case, if you take, then what is going to happen? Q2, Q1, initial state was 0, 1. Okay, so both will be just copied, but crisscross. 0 will come here, 1 will come here. No complement. 1 will come here, 0 will come here, and here only repetition occurred. Okay, here only repetition occurred, and this time it becomes a mod 2 design. Okay, because it becomes a mod 2 design, the frequency at the MSB will be 1/2 of the clock frequency, and half of 1 megahertz will be 500 kilohertz. Right. So even this was accepted. Even this was accepted. So 200 or even 500. Chalo. Okay. So these are the questions that is there from the digital circuit. Okay. Let's move ahead. So now we have the question from signal and system. Consider a system with the input xt and the output yt is equal to x of e power t. What is the system equivalent to? Okay, so what is yt? Very simple. Whether it is causal or non-causal, that is just a one-step calculation, because it's all about relating future and present. So even if you take the, very simple time t equal to 0, what is y0? It is equal to x of e power 0, but e power 0 is 1. Okay, now to calculate the output, at t equal to 0, you need the value of the input. You need the value of the input at t equal to 1, and that is what is future. So you are going to future. If this is the present, okay, t equal to 1 is the future, and that is why the system is non-causal. Whenever the output depends on future values of the input, system is non-causal system. Okay, now time variant or time invariant, वो भी निकाल लेते. So we have the relation yt is equal to x of e raised to the power t. Okay, now first case, let us delay the input, okay, and calculate the output. Let us calculate the output when the input is delayed. So input delayed, suppose by t naught. Okay, so it will look like e power t minus of t naught. But second case, if you directly delay the output by the same amount, what does time invariant say? A time shift in the input should produce a very similar time shift in the output. Okay, so if I give the same time shift in the output, it should be equivalent to the output obtained when the input was shifted. So dekhte hain, y2t minus t naught, that is going to be how much? Sorry, this is y2t, which is going to be y of t minus t naught. The original output is y, I shifted by t naught, and this is going to become x of e power, see, t is going to be replaced here. Okay, so the t in the exponent will become t minus t naught, and definitely these two do not match. Clearly, this is the approach you must have studied, na? y1 does not equal to y2, and the system is time variant. The system is time variant. It cannot be time invariant. So non-causal to hai and time variant hai. Correct answer is option number B. Correct answer is option number B. Moving ahead to the next question from signal and system. Okay, 1 mark question again. Let MT be a strictly band limited signal with bandwidth B and energy E. Assuming omega naught equal to 10B, 10 times B, what is the energy in the signal MT cos omega naught T? MT cos omega naught T. Okay. MT cos omega naught T. Modulation. Whenever a signal is multiplied by cosine signal, okay, its spectrum is shifted to higher frequency centered at omega naught. Right. So, if I assume, see, this is MT, right? Let MT have the Fourier transform m omega. So let's assume this. Those no signal given, but roughly, like let us assume that, let's say this is. Let's say this is some random spectrum m omega, which is having the bandwidth of B and energy of E. It could be any type of spectrum. For bandwidth, only positive frequency are considered. So if bandwidth is B, it should be 0 to B here, and on the left side 0 to minus B, and it has some energy E. right? It has some energy which is taken as E here. Okay. Now what is the next signal given to you? The next signal is mt cos omega naught t, right? So you have a signal yt which is mt cos omega naught t. Let's say the Fourier transform of yt is y omega. What is the modulation theorem? Okay, it says that the Fourier transform of mt, that is m omega, will be shifted to higher frequency, that is m of omega minus omega naught plus m of omega plus omega naught, and amplitude whole divided by 2. This is what is the modulation theorem, okay, that you study in the Fourier transform. Okay, so let me see how the things are going to be. Okay, let's say this is going to be the spectrum that is known as y of omega, and what is going to happen? It is going to be centered at omega naught. Now what is the omega naught? The value of omega naught is 10b. The value of omega naught clearly mentioned in the question is 10b, right? So if it was centered at origin, it is going to be now centered at 10b, right? Okay, so it was up to b, now 10b plus b, this is going to be up to 11b, and this will be 9b, right? But suppose the amplitude here was a, the amplitude, peak amplitude here will be a by 2, right? And the symmetric portion, left shifted also, you get two parts here, so minus 10b, and that symmetric spectrum, let me draw, this is going to be minus 9b, this will be minus 11b, again with the amplitude a by 2. So guys, the calculation that is left for you, suppose this energy is E1, what is going to be this energy? The shape is same, even the total duration, this is 2b, this is also 2b, so there is no change in the total duration. But whenever the amplitude of a signal is half, energy will become 1/4. Whenever the amplitude is multiplied by k, energy is multiplied by k square, because energy is proportional to square of amplitude, so its energy will become 1/2 square of the energy E. And even this energy, okay, is suppose E2, that also will become 1/2 ka square multiplied by E. So the total energy, okay, so the total energy here, because they are asking energy in the question, what is the total energy is going to be 1/2 ka square is 1/4. So 1/4 of E plus 1/4 of E, that is E by 2. You can remember the result by the effect of modulation theorem also, but yeah, just I have, derived this and proved this for you. Not a very big deal. It is going to be E by 2. It is going to be E by 2. Next, the Fourier transform of xt is equal to, this is a direct question, Gaussian signal, e power minus t square. This is given in case you are deriving. But yeah, for a 1 mark question, at least you should know, and at least you should know the Fourier transform of very common waveforms and important signals. So Gaussian is an important signal. E raised to the power minus at square has the Fourier transform root over pi by a e raised to the power minus omega square by 4a. That is the Fourier transform of Gaussian pulse, which is again a Gaussian nature only. And if I just put a is equal to 1, I would be getting e power minus t square. This is what directly I am using it. Okay, we'll have the Fourier transform root over pi by 1, that is root pi e raised to the power minus omega square by 4. Root pi e raised to the power minus of omega square by 4. That is the option number C. Root pi e raised to the power minus omega square by 4. Done, eh? Let's move ahead to the next question. In the table shown below, match the signal time with its spectral characteristics. This is a factual question. You must be knowing it. If the signal is continuous and say fractal or property, you can say. Okay, basically concept, when you have studied all the concepts, what do you do with continuous signal? What do you do with the discrete signal? So continuous and aperiodic signal, normally when you calculate its Fourier transform x omega, that is also continuous but generally aperiodic. Okay, so this is going to be matched with A, right? It is going to be matched with A. Continuous and periodic. Now for continuous and periodic, still you continuous signal, so we calculate the CTFT. Fourier spectra ki baat kar rahe hai na. But what is the nature of the Fourier transform of periodic signal? What is the nature of the Fourier transform for periodic signals? If you just try to recall into that mind, it turns out to be 2 pi summation for all values of k, ck, where ck as the Fourier series coefficient, delta omega minus k omega naught. It contains various impulses. Okay, but the area or the weight of every impulse is not the same. So that is why it will not be a repetitive periodic signal, but it will be discrete because it only contains impulses. Okay, at omega naught, at 2 omega naught, at 3 omega naught. Okay, there will be some impulses, but the weight of this or area of the impulse depends on the Fourier series coefficient. That depends on the signal. So we cannot say it is periodic, but at least it is going to be discrete in nature. It cannot be continuous. Okay, it cannot be continuous. So it is discrete, but not periodic. It is discrete and aperiodic. It is going to be matched with the C. It is going to be matched with the C, discrete and aperiodic. Now, discrete and aperiodic signal, we calculate the DTFT, and DTFT is always periodic. DTFT is continuous and periodic. Okay, so continuous periodic, यहाँ पे B आ जाना चाहिए, right? Discrete and periodic signal, for discrete and periodic signal, we calculate the DFT actually. Okay, the DFT, which is like XK, which is also discrete, but at the same time periodic, which is discrete and periodic. D यहाँ पे match हो जाएगा, तो it should be in the form of ACBD. ACBD, option number B. Option number B. Okay, option number B. Let's move ahead to the next. Right, consider a discrete time periodic signal with the period 5. Now this is a good question. I'm not telling it is a difficult, it is easy only, but little bit property. You have to be good with property, and good with property means yes, approach. जहां practice ज़्यादा है उनके लिए क्वेश्चन इजी होगा. कंसिडर अ डिस्क्रीट टाइम पीरियोडिक सिग्नल विद द पीरियड 5 एंड लेट द DTFS बी गिवन टू यू. xn इक्वल टू समेशन a k e power j k 2 pi by 5n, where a0, a1, a2, a3, a4, some Fourier series coefficients are given to you. Ak are what? In this representation, Ak are known as the Fourier series coefficients, the DTFS coefficients actually, right? The value of the sum, summation xn, sine of 4 pi n by 5. Now listen, summation of xn, sine 4 pi n by 5. This Ak, which are the discrete time Fourier series coefficient, what is the formula for Ak? Everybody, just try to recall that in mind, you'll get your answer. The formula for the DTFS coefficients is given by 1 upon n summation of xn e raised to the power minus j k omega naught n, e raised to the power minus j k omega naught n, where of course omega naught is given by 2 pi by time period, which is 5 here, 2 pi by 5, omega n ka value 5 hai, right? So what is the Ak? It is going to be 1 by 5 summation of xn e raised to the power minus j k 2 pi by 5 into n. Now by the virtue of this question solve हो जाएगा, because what you have to do, summation xn sine 4 pi n by 5. Okay, first of all break the sign into the Euler's identity. Okay, so let us come to the required expression. Summation of xn sine of 4 pi n by 5. Sine of 4 pi n by 5. Okay, summation for n equal to 0 to 4, correct. So that is going to be, because here also when you do the summation, this summation is n equal to 0 to n minus 1 in general. So that is why it becomes 0 to 4. Ab dhyan dena. Sorry, let's go back here. So this is going to be, इसको यहाँ लिखते हैं पहले. So this is going to be summation of xn, applying the Euler's identity, it should look like e power j theta, so e power j 4 pi by 5n, okay, minus e raised to the power minus j theta is divided by 2j, where summation is from 0 to 4. Now dear, 1 upon 2j ko kar do outside, right? And then look into this pattern. You have summation of xn e raised to the power j, let me write it as minus j, because in this expression we have minus j k 2 pi by 5 into n. Let's say the k is 2, because here it is 4 pi by n, so e power minus j into 2 pi by 5n, right? Similarly, the other term would become how much? Okay, the other term would become how much? इसको भी हम कॉमन ले लेते हैं, xn को कॉमन ही ले लेते हैं. Okay, the other term would be e power minus j, right? Minus j, यहाँ पे plus था ना, so this should be minus 2. Sorry, let me write this as minus 2. E power minus j minus 2, so that total it is plus. In the second term, no need to write down minus 2. E power minus j 2 pi by 5 into n. Correct, everybody? Now decide what are these. This is 1 upon 2j. Okay, summation, let's come here. I can write down that summation of xn e power minus jk 2 pi by 5n should be equal to 5 of ak. 5 of ak, right? So in this, what is the value of k? Minus 2. So this should be 5a of minus 2. Minus 5, here the value of k is 2. So a of 2, right? This is what is the value of k. This is what is the value of k, right? Acha, what is a minus 2? That is not given, na? What is a minus 2? What is a minus 2? A of minus 2 will be a of minus 2 plus 5. That is going to be a3. Why? Because ak is in general ak plus n. The discrete time Fourier series coefficients are periodic in nature. Okay, are periodic in nature. Rest only value given. So I need a3 here actually. 5a minus 2 will be 5a3. Then 5a2. Put down the value. What is the value of a3? Okay, minus 2j. a2 is plus 2j. Putting down the value, I have 1 by 2j 5 into minus 2j. a3 is minus 2j, correct. Then minus 5 into plus 2j. 5 2s are 10. 10 minus 20. So 1 upon 2j is going to be multiplied with minus 20j, and hence the answer jj cancelled. Answer is minus 10. That is clearly option number A. The answer is the minus 10. So this one is a good property test. Okay, not difficult, but property application. Good practice if you have done with DTFS and DFTs, DTFT. This will give you the 2 marks. And every year we expect question on DTFS or DFTs or DTFT, at least one question for 2 marks. We expect this. Usually good property based only. Now next question. Let an input xn have the discrete time Fourier transform x omega. X e power j omega is 1 minus e power j omega plus 2 e power minus 3a j omega. यहीं से simplify कर देते हैं that in general what is the DTFT? Okay, we can write it as x omega or x of e power j omega, one and the same thing. It's ultimately a function of omega. Okay, is known as summation of xn e raised to the power minus j omega n, correct? Right, for all values of n from minus infinity to infinity. Now here only 3 points are given. Okay, here only 3 points are given. So what does it mean? From this particular x of e power j omega, what is the signal that you are able to guess? The first is 1. When will you get 1? When will you get 1? Okay, when you have e power minus j omega into 0. Okay. Okay, when you take n equal to 0, right? So e power 0 will be 1. You are only left with the value of the signal. So that should be 1. So pehla signal ka value 1. Then next is e power minus j omega. When will you get minus j omega? When n is equal to 1. Okay. Okay, so when n equal to 1, what is the sample left? x1. Okay, what is coming up here? Minus 1. So x1 should be minus 1. The next value is minus 1. Next is e power minus j 3 omega. Directly 3 omega. So sir, where is 2 omega? Not given. That means x2 must be 0. That means x2 must be 0. Then only e power minus j2 omega term is not there. Then e power minus j3 omega coefficient is 2. So n equal to 3, x3. But what is x3? x3 ka value 2 hoga. This is the xn. Okay, so we have first obtained what is the xn. Similarly, on the information of h omega, what is the hn? What is the hn? Again 1. 1 means 1 into e power minus j omega 0. Okay, n equal to 0. So this should be h0. Okay, so the h0 is equal to 1. This is the this was the x0. Let me mark the origin. This was the origin value. N equal to 0 वाली value को हम arrow से mark कर देते हैं. Similarly, here also this corresponds to the value of n equal to 0. Then directly e power minus j2 omega. Sir, where is 1 omega? N equal to 1 is not there. So the value of the signal at n equal to 1 is 0. Then directly n equal to 2. For n equal to 2, I should have x of half. Sorry, h of half. So what is h of half? Minus half. For n equal to 2, I should have h2. What is h2 is minus half. So we have both the signals now. Okay. What is the output of the system? So there was one way you multiply both the DTFTs, solve the multiplication change and then take the ITFTA. Or next is simply, I just prefer to take it as the convolution. Because anyways, multiplication also you will spend some time. Better I can just convolute. So what is the output yn? The output yn is xn convolution hn. And why convolution is simple? Because it is Because it is finite length discrete time signals for which convolution is just sum by column. Very simple tabular method you can follow. Okay, so you have one of the signal as 1 and -1 and 0 and 2. 1, -1, 0, 2. Other one I will write vertically, that is 1 and 0 and -half. Okay, now multiply 1 with all the elements on top. So 1, -1, 0 and 2. Next multiply with 0 and write down the answer 1 unit right shifted. Next multiply by -half and again write down 1 unit right shifted. So -half into 1, -half into 1, -half into 0 and -half into 2 will be -1. Okay, and just sum by column. So 1, -1. Okay, this looks like -half. This is 2 plus half, 5 by 2. This is 0 and -1. Okay, both the signals started at origin. Okay, this was the arrow, this was the arrow. So output will also start from origin. Sum of starting point property. Okay, the sum of starting point of yn is equal to sum of starting point of xn and hn. Okay, the starting point of xn and hn is origin. So 0 plus 0, this also will start from n equal to 0. So here arrow. Now what is this in a sense? This is like, now I want to represent in the form of impulses. Right, this is the value at origin is 1. So this is 1. पहले इसको sample में लिख देते. Then I have -1, -half, 5 by 2, 0, -1. Now let us match in the form of impulse. So this is the value at origin. The impulse at origin delta n. Then this will be right shifted impulse delta n -1. So my answer will start with delta n. Okay, all of them are starting with delta n. Next is minus delta n -1. Next is minus delta l -1. So A and D ruled out. Right, A and D ruled out. Next is -half delta n -2. -half delta n -2. So ये यहाँ पे भी save है. Okay. Next is +5 by 2 delta n -3. +5 by 2. So this is ruled out. Okay. Only C is left. Still let us match up completely. What is next? Next is 0. So delta n -4 will be absent. Everywhere delta n -4 is absent. Okay. And then -1 delta n -5. Yes, look into this. -1 delta n -5. The correct answer is option number C. Matching up with all requirements, all our calculations, the correct answer is option number C. The very correct answer is option number C. Moving ahead to the next question now. Right. Okay. Chalo, again a good question here. Let xt is equal to 10 cos 10.5 Wt be passed through a LTI system having the impulse response ht is equal to pi sin Wt by pi t whole square into cos 10 Wt. What is the output of the system? What is the output of the system? Again, cosine multiplication is going to play a role. Again, the cosine multiplication is going to play a role. So have a look into this. xt is equal to 10 cos 10.5 Wt. Okay. It is passed to a system having the impulse response pi sin Wt upon pi t. So let's first of all little bit modify this. What is this? ht. This is given to you as pi. Okay. Sine of Wt ka square. Okay. But pi, let me bring the pi square outside actually. And inside, let me shift W. Now please note that. Please note, sir, there was a pi inside the square, so I bring it outside, it becomes pi square. But there is no W inside, so I bring a W inside in the denominator, so I have to take the W in the numerator also. Achha, that too it is W square, so I should multiply separately by W square, so that this W square will get cancelled. Okay, why I am doing this, it should be logical to you, because sin theta by theta is the sampling function. Okay, then it is multiplied by cos of 10 Wt. Okay. So, what is the impulse response? One of the pi will get cancelled. W square को आगे लिख लेते हैं. W square upon pi. This becomes the sampling function. Sampling square Wt into cos of 10 Wt. Okay. Now, use the Fourier transform for sampling square. Use the Fourier transform for sampling square. Okay, what is the Fourier transform for sampling square? Sampling square AT has the Fourier transform which will be a triangle function. For sampling it is rectangle, for sampling square it is a triangle function. It has the Fourier transform which is pi by a tri of omega by 2a. What do we have? We have actually sampling square Wt. Sampling square Wt should have the Fourier transform pi by w tri of omega by 2w. Okay, but then we also have W square by pi multiplied. We have W square by pi multiplied. So let me multiply here only. W square by pi multiplied both the sides. Linearity property of the Fourier transform. W square by pi, pi to pi cancel हो जाएगा. Okay, and this looks like W tri omega by 2W. And then we need to multiply by cos. But to multiply by cos, we'll directly use the modulation property. Okay. So guys, what is this much of the spectrum? What is this spectrum? If I just have a sketch of this. Okay. Tri of omega by 2W. It's a triangle signal starting from minus 2W going up to the 2W, symmetric triangle signal. The total width is 2W. This is up to 2W, this is minus 2W, and total width, sorry, 4W. And the amplitude, if it was not mentioned, the triangle height is 1, but it is W into tri, so height will be W. But this is only the spectrum of W square by pi sampling square WT. This is not HT. HT is further multiplied by cos WT. So what is going to be its spectrum? वो next slide पे sketch कर देते हैं. So what is the HT given to me? HT is W square upon pi, correct? W square by pi sampling square WT multiplied by cos of how much? Cos of 10 WT. Cos of 10 WT. So in a sense, again you apply the modulation theorem. You can say there is some omega naught which is 10 W, and this is going to do what? Already I explained you the modulation theorem in one of the previous question. Let's directly draw the waveform rather than explaining it again. Right. I think 6 or 7 number question probably, where we were finding the energy, but here it is little bit more better question, so it went for 2 mark. Shift its spectrum to higher frequency once at 10 W, once at minus 10 W, and amplitude divide by 2. Don't forget, the amplitude will be divided by 2. The amplitude would be divided by 2. So let's do this part. Okay, so this is at 0. Okay, so this is going to be at 10 W. Okay, and minus 2W to plus 2W will look like 8 to 2. 2W here, 2W on this side. So 8W up to the 12W. This is 12W, this is 8W. And the amplitude, which was W, will now be restricted to this particular amplitude, should now be restricted to W by 2. Similarly, a symmetric portion on the left side as well. Minus 10W from minus 12W to minus 8W with the amplitude equal to W by 2. Correct? Now let us look into the given signal. This is the impulse response. This is the system information, and this is the frequency response actually. Okay, this is the frequency response H omega of the system. And now I have an input given to you, which is a sinusoidal input 10 cos 10.5 WT. Okay, 10 cos 10.5 WT. Okay. What is the input given to me? It is 10 cos of 10.5 WT. Okay, it's a sinusoid signal. It's a sinusoid signal having some frequency omega, which is 10.5 W. And whether it is the pass band or reject band, it is going to pass all the frequency from 8W to 12W. So it is in the pass band. This frequency is in the pass band, because if it was not in the pass band of this filter, it is going to multiply the signal by 0, and hence the output would be 0. So here we have a sinusoidal signal. Okay, that is of the frequency which is in the pass band of the filter. Now let's move ahead. Okay, that to the frequency is 10.5. The frequency is 10.5. So where is the 10.5? Let me highlight the 10.5 here. Okay, let me highlight the 10.5. This is the omega, which is the 10.5 W. What is the gain of the filter at that frequency? ये निकालना पड़ेगा अभी. What is the gain of the filter at that frequency? How much is this gain? How much is this gain? Okay, how much is this gain? Let us use the concept of slope, because whether you use this portion or whether you use this entire line, it is one and only one straight line, so you can calculate its slope. You can calculate its slope. So what is the slope here? The slope. Slope is change in y. What is the height? W by 2, overall height, and overall base 2W. 10W se 2W liya, that is 2W. This should be equal to the slope of this particular portion as well. Okay, what is the slope of this portion? Change in height. That is what I want to know. What is the change in height? W by 2 minus this gain. Okay, minus this gain. Okay, let us say this point gain is something gain only. But what is the change in base? 10W से 10.5W. So the change is 0.5W in the base. Change in height upon change in base, that is the slope. Okay, so W by 2 upon 2W, that is 1 by 4. Okay, 1 by 4 is equal to W by 2 minus gain is divided by 0.5W. Okay, so let us simplify this here. So I get W by 2 minus gain. Yeah, let me save some space here. यहीं पे लिख देते हैं. I have W by 2 minus of gain is equal to 1 by 2 into multiplied 1 by 4 of 0.5 W. Okay, so W by 2 will be equal to, not W by 2. Let me write down the gain only now. So what is going to be this gain point? It is W by 2 minus, this is 1/4 of 1/2. So that is W by 8 in a sense. Okay, so that will be 3W by 8. This will come up to be 3W by 8. Okay. So the sinusoid is having the frequency of 10.5W, which is in the pass band. And what is the gain of the system? What is the gain of the system at omega equal to 10.5W is 3W by 8, and hence eventually I can write down the output. Hence eventually I can write down the output as the system gain multiplied by, and that is how you find the output for sinusoids. Huh? For sinusoids it is easy to do this way. Okay, so 10 into 3W by 8 actually cancel by 2, so it becomes 5, 15W by 4. Okay, the answer should be 15W by 4. 15W by 4 into the cos omega t. This is again a good detailed question. 15W by 4 cos 10.5 WT. Option number A. That is why I told signal and system questions were little on the good side, and as well as EDC. Okay, this is option number A. Let's move ahead to the next. Okay, 13. Let x1t is ut plus 0.5 plus 1.5 minus ut minus 1.5, and x2t is shown in the figure. For yt is equal to x1t convolution x2t. Okay, I think the data is slightly whitish here. I'll write down with black again. The integral minus infinity to infinity yt dt is equal to how much? Now, very fundamental law if you apply, integral minus infinity to infinity yt dt is known as area of yt, correct? That is known as what? That is known as the area of yt. And what is the area of convolution? Yt is x1t convolution x2t, and area of convolution is given by the product of areas of both the signals. So that should be area of x1t is multiplied by the area of x2t. Area of x1t multiplied by the area of x2t. Okay. Right. Now, what is the area of x2t? This is simple, na? ये तो यहीं से निकाल लेते हैं. What is the area of x2t? Area of impulse 1 plus area of rectangle, that is height into base. Height is 1 and base is 2 units. Plus area of next impulse, which is mentioned as 2. So this is 2. So 1 plus 2 plus 2, this is 5. Okay. What is the area of x1t? So what is the signal x1t actually? What is that signal x1t? Let me draw here only. Let me draw the signal x1t here only. And x1t is ut plus 0.5. Difference of 2 unit steps will give you that rectangular signal. Ut plus 1.5. Left shifted step signal starting from minus 1.5, having the amplitude 1. It would have continued till infinity, but there is another step signal of amplitude minus 1. So 1 minus 1 will become 0 at t equal to 1.5. At what? At t equal to, at t equal to 1.5. At t equal to 1.5. Okay, this is stopped and this becomes 0. So that is a rectangle signal. And for this rectangle signal, what is the area? It is again height into total base minus 1.5 to 1.5, that is equal to 3. Okay, so let me put up the area of the first signal is 3. The area of the second signal is 5. Very, very simple question. The answer is 15. Answer is 1515. That's it. The correct answer is 15. Okay. A very simple question basically. Okay, and now guys, next let me invite Sanjay Rathi sir, and he is going to deal with the upcoming subjects like EDC and moving forward guys. So understand very well, as I told you, EDC also is on the slightly trickier side, so understand the question. Now all your favorite Sanjay Rathi sir will join and carry forward with the questions.
Thank you Rakesh sir, and hello everyone, welcome to the BYJU'S exam prep. This is Sanjay Rathi. Now I will discuss question from electronic devices and analog. Now the first question on screen, that is, in a semiconductor, if the Fermi level lies in the conduction band, then the semiconductor is known as. This is a very simple theoretical question, and the answer for this question is degenerate N type. So we can take this answer, and this is a 1 mark question. That is the answer for this question, because where is the Fermi level? Fermi level is inside the conduction band. This is EV, this is ECE, and this is the Fermi level. It is an N-type bar, definitely, but the doping is very, very high, and that's why Fermi level is inside the conduction band. Now, next question. For an intrinsic semiconductor at a temperature T equal to 0 degree Kelvin, which of the following statement is true? You can read all these statements, but remember, at a 0 degree Kelvin, intrinsic semiconductor behaves like insulator. And that's why, according to energy band diagram, this is the energy band. Then this is EC, this is EV, this gap is called forbidden energy gap, and all the electrons will be in valence band, right? Because there is no sufficient energy, therefore the electron will not switch from valence band to conduction band. So what is the number of what is the concentration of electron in conduction band? 0, right? And all energy state in valence band are filled with the electrons, and all energy states in conduction band are empty of the electrons, and that is the right answer for this question. And semiconductor behaves like insulator. Then next one. For a MOS capacitor, VFB means flat band voltage, and VT are the flat band voltage and the threshold voltage respectively. The variation of the depletion width for varying gate voltage is best represented by. Okay, now guys, what is given here? This is the flat band voltage. We are increasing the voltage from this point to this point. On x-axis we are increasing the voltage, that is called VGS. Remember what is the diagram here? Now this is the semiconductor. Here we are giving the VGS. This source is normally connected to ground, and that is we are connecting the VDS. We are talking about the CMOS, this is MOS capacitor. So when we are applying the voltage at this point, when it is highly negative, then it is in accumulation mode for N-channel MOSFET. This is p-type body. Okay, then there will be the flat band. Just after the flat band voltage, depletion width will start increasing. Okay, and exactly at threshold voltage it will reach to maximum, and after threshold voltage inversion will start, and that is the characteristics of MOSFET. CV characteristics of the MOSFET here. Now, this is the accumulation mode. After flat band voltage, depletion will start increasing, and at threshold it will reach to maximum, and after that inversion, and then strong inversion occur. This is the VT, and that is the flat band voltage. So before flat band voltage, what is the depletion width? 0. It start increasing from this point to this point, and it will reach to maximum at VT, and after that the depletion width will remain constant. And that's why, watch this answer. Here the flat band voltage depletion width start increasing, on y-axis it is a depletion width, and at this point at 0 voltage it reached to what? Maximum. After that it is saturated. That's why it is wrong. At flat band voltage depletion width start increasing, before that it is 0. Yes, correct. At a threshold point it is almost constant, and after that it is constant. That's why the answer B is the correct one. So this is the curve between depletion width and VGS. Okay, not between C and VGS. Already I have given the curve between CV characteristics. So that answer B is the correct answer for this question. Next question. In an intrinsic semiconductor, the hole concentration is given to be 1.5 times of intrinsic carrier concentration. And what is the Ni? 1 into 10 raised to power 10. The ratio of the electron to hole mobility for equal hole and electron drift current. For equal hole and electron drift current. Okay. Now watch this. Yes. This is a semiconductor. What is the concentration of hole? P is given by 1.5 times of Ni. So what is the concentration of electron? According to mass action law, it is given by Ni square by P. We can say Ni square by 1.5 Ni, and therefore the concentration of electron will become Ni by 1.5. Right? Since according to mass action law, Pn is equal to Ni square, that is constant. Okay. Now, what is the intrinsic carrier concentration is given? The ratio of the electron to hole mobility for equal hole and electron drift current. So this is the drift current because of the electron, and it is given by A, Jn. A, what is the J? Current density. That current density is given by sigma E. And what is the sigma? A n q mu n into electric field. What is the IP? A jp. A sigma E. What is the sigma for p type? A p q mu p into E. That is, we are applying the same electric field. And then find the ratio In by Ip. In by Ip, that is given, these currents are equal. Then A cancel. You will get N by P into QQ cancel, mu N by mu P, EE cancel. Then from this you will find N by P, because In by Ip is equal to what? 1. In by Ip is equal to 1, that is given in the question because these two currents are equal, drift currents are equal. Therefore, mu N by mu P, mu 1 by mu P will become, 1 minute. Now, mu n by mu p is nothing but p by n. And what is the p? 1.5 ni. And what is the n? Ni divided by 1.5. And that's why you will get the 1.5 square. This is nothing but 2.25. So answer for this question is 2.25, and in key the range is given as 2.20 to 2.30. That is given by the IIT. Okay, so 2.20 to 2.30. So this is the question. 2.25. This is the answer for this question. Next one. Now, again the question from what? Electronic devices and circuit. In a semiconductor device, the Fermi energy level is 0.35 electron volt above the valence energy band. Valence energy band, what is the valence energy band? Then we can Draw a diagram. Okay. This is the case. This is EC. This is EV, and this is the Fermi energy level. Okay. Now, what is this gap? Is given as 0.35 electron volt. Okay. Now, according to the formula, this gap is given by EF minus EV, KT log of Na, that is density of states upon concentration of holes. This gap is given as 0.35 electron volt. Then what is the value of Na? It is given as 1 into 10 raised to power 19 at 300 degree Kelvin. The thermal equilibrium concentration in silicon at 400 degree Kelvin means what is the temperature? 400 degree Kelvin it is required. And what is that? It is into 10 to the power 13. To round it off to 2 decimal places you have to find, and KT is given as 300 degree Kelvin is 0.026. So first of all, if you want to use this formula, then you have to find the value of Na at 400 degree Kelvin. You have to find the value of the KT at 400 degree Kelvin. So what is the formula here? What is the formula here, guys? Now watch this. First of all, Na2 by Na1. Na2 means value of Na at temperature T2 and value of Na at temperature T1. This will become T2 by T1 raised to power 3 by 2. So what is the Na2 at temperature T2 is given by T2. What is the T2? 400. What is the T1? 300 degree Kelvin raised to power 3 by 2 Na1. And this will become 4 by 3 raised to power 3 by 2 into Na, 1 into 10 raised to power 19, that is given in the question. Calculate. Right? So 4 by 3 into 3 by 2 into 10 raised to 1 into 10 raised to power 19. So you will find the Na2. Right? Na2. Now, once you will get the value of the Na2, leave it here. Then, second thing, find KT2. So what is the KT2 by KT1? Right? If you want to find this ratio, KT2 and KT1 at temperature 2 upon at temperature 1, by K is same, so this is nothing but ratio of T1 and T2 and T1. So what is the KT2? Is given by 400 divided by 300 into KT1. This will become 4 by 3 into 0.026. Right? That is the value of this. Okay. Now, you can use this value. You can use this value to find the value of P. So, what is the P? Now, from this formula, this is given as 0.35. Now, 0.35 is equal to KT2 at temperature 400 degree Kelvin log of Na2 upon P. Now, this is divided and take the anti-log of that. So, this is 0.35 divided by KT2 and anti-log will become e raised to power 0.35 divided by KT2 is equal to Na2 by P. And therefore, finally you will get the P is equal to P Na2 divided by e raised to power 0.35 divided by KT2 at temperature 400 degree Kelvin. Now I am going to use this formula. What is the formula? P is equal to e raised to power 0.35. Now, what is the P? 4 by 3 raised to power 3 by 2 into 1 into 10 raised to power 19 e raised to power 0.35 divided by KT2. Now you can find the value of the KT2. This is a very simple thing. 4 divided by 3 into 0.026. It is around 0.03467. 0.03467. Okay. 0.03467. So what is the value here? Reciprocal of this into 0.35 e raised to power this value, and now into 4 divided by 3. Yes, and finally you will get 63.48 into 10 raised to power 13. 63.48 into 10 raised to power 13 per centimeter cube. And that's why the answer for this question is what? 63.48. Answer is given in the range from I think about 62 or 63 to what up to what 70, right? But in this question, this in a semiconductor device, the Fermi energy level is 0.35 electron volt above the valence band energy. That is, temperature is not mentioned here. This value is at 300 degree Kelvin or it is at 400 degree Kelvin. It is not mentioned here, and that's why we are taking it as a constant. The effective density of state is given as 300 degree Kelvin. KT at 300 degree Kelvin is given, but this is nothing about what Fermi energy level 0.35 above. Temperature is not mentioned, and that's why we are taking it what? Constant. Okay, or we are taking the same value for 400 degree Kelvin. Right. Next one. 19th question. Now guys, this is a question from analog circuit. 1 mark question, MCQ. In the circuit shown below, V1 and V2 are the bias voltage. Bias means we are giving the DC biasing, right? So this is the V1 and this is the V2. Based on the input and output impedances, the circuit behaves as a. Now we are giving the input at this point. Remember, we are giving the input at this point, and that's why it is a source. Are you getting this point? That's why it is a source. This is the source terminal and this is drain terminal. Which terminal is common? Gate terminal is common, because we are giving the input and we are taking the output from the drain. So this is a common gate configuration. This is a common gate configuration, and this will act as a load. This will act as an active load. Now what is the common gate configuration? In case of common gate configuration, remember this is similar to what? Common base configuration. When we are comparing with the BJT, it is similar to common base configuration. For common gate configuration, input resistance is very low. Input impedance is low and output resistance is very high. Now, if the input resistance is low and output resistance is high, then this is the amplifier. We are connecting a current source here, and we want the input resistance of that amplifier should be as low as possible, so that the complete current will pass through the RI. RI should be very less as compared to RS. Now output resistance is very high. Again, this is the output resistance, and here we are connecting the RL, and current gain is almost 1. Then this is the output resistance. We are getting the I naught dash. This complete current will pass through the RL, and that's why, because R naught is very high. R naught is very greater than RL. So basically it is a current controlled current source. It is a current amplifier. It is a current controlled current source, right? This is a similar to what? Common gate, we can say. Common gate and what? Common base. Common gate in case of FET or common base in case of BJT. Input resistance very low, output resistance very high. Now Which answer is correct? Current controlled current source. D is the correct answer for this question. D is the correct answer for this question. Next question. A cascade of a common source amplifier in a unity gain feedback configuration oscillates when? This is based on what? BARC-Hussein criteria. And according to the BARC-Hussein criteria, actually what is the BARC-Hussein criteria? If it is the basic amplifier, then it is called feedback path. This is the A, this is the beta. The signal again reached to what? Vi. This is called feedback signal VF, and when VF is exactly equal to Vi, then there will be the oscillation. That is the condition. So what about the loop gain? Loop gain means mod of A beta should be exactly equal to 1. And if it has 180-degree phase shift, for example, cascade of common source amplifier. So for common source, phase shift is 180-degree. It is similar to what? Common emitter. If the phase shift is 180-degree, so what should be the phase shift provided by the beta network? It should be equal to 180-degree. So that the total phase shift is in a closed loop is 360-degree. But what is the condition given? Closed loop gain is less than 1 and the phase shift is less than 180. Closed loop gain greater than 1 and the phase shift is less than 180. So all answers are related to what? Closed loop, but is the condition on the open loop. And that's why in this year this question is given to what? Marks to all, MTA. This question is rejected here. So no need to waste your time on this type of questions. Simply remove it. Simply remove it. It is based on BARC-Hussein criteria. Now, in this question, try to understand. This is a question. The V out by V in of the circuit shown below. Circuit shown below, it is given. Watch this diagram, everyone. This is a non-inverting, this is a inverting operational amplifier, because where is the V in is given? Try to understand. It is given to the negative terminal. Positive terminal is connected to ground. So when I am calculating the output at this point, like this is the V01, since it is a non-inverting operational amplifier, therefore gain is minus RF by R1. So what is the RF? R2, R1 into what? V in. That is the output at this point. Now, what is this? Input is given to positive terminal and feedback is through negative terminal. And that's what is a non-inverting operational amplifier. What is the gain for the non-inverting operational amplifier? It will become 1 plus RF by R1, R2 by R1. 1 plus R2 by R1 into what? V in. What is the V in here? This is the positive V in. Now, watch this diagram. This diagram is what? Summer. This is a inverting summer. Now I am going to draw this diagram and we have the output. Then this is a summer. Now, what is the output of the summer? Output of the summer is given by minus R4 by R3 into V01, minus R4 by R3 into V01, minus R4 by R3 into what? V02. This is the output. Now you can take the R4 by R3 common, minus R4 by R3 is common, it will become V01 plus V02, and that's why it is called summer. We are adding. Already we have calculated the V01. This is the output of inverting operational amplifier. Therefore, we can write V0 is equal to minus R4 by R3. What was the V01? Minus R2 by R1 into V in. And what is the V02? Plus 1 plus R2 by R1. That is the non-inverting operational amplifier into V in. Now, it is visible? Yes. Now, this R2 by R1 and that R2 by R1 is cancelled out, and you will get V0 is equal to minus R4 by R3 into V in. Therefore, what is the V0 by V in? V0 by V in will become minus R4 by R3. Minus R4 by R3. 3, and that is a simple answer. Inverting, non-inverting, this is connected here. This is the inverting operational amplifier, non-inverting operational amplifier, V02, V01. We are adding, this is the inverting summer. This is the inverting summer, right? So first of all, add these two. So minus R2 by R1 minus plus R2 by R1 cancel out, and it will become minus sign. So minus R4 by R3. This is the answer. Easy. A is the answer for this question. It is of 2 marks. Analog circuit. Okay then. Next question. Now that is the question on what diode, multiple diodes, or we can say the question on what clipper. Then you have to find the V out versus V in. Transfer curve is given here. In the circuit shown below, D1 and D2 are silicon diodes. These are the practical diodes. And what is the cut-in voltage is given? 0.7 volt. V in and V out are the input and output voltages in volt. V in and V out are output voltages in volt. The transfer characteristics is. The number of transfer characteristics is given. Guys, you have to find the answer. So what is the proper approach? Then I will give you the shortcut. Then first of all, what is the diagram given? Redraw the diagram. These are the practical diode. One resistor is connected here and 1 volt battery is connected here. We are calculating the V0 here. This is the resistor, 1 volt battery, and here V in is given. Okay, first of all, how we can draw a diagram? Write the table here. This is called systematic approach. What is the range of the V in? What is the position of the diode, and what is the output? First of all, watch the graph. When I am watching the graph given in the question, from negative to positive, from negative to what? Up to positive value. So you can choose any negative value, minus 10, minus 20, right? So when I am choosing any negative value, let's minus 10. So V in vary from minus 10 to plus 10. V in. When it is minus 10 here, definitely this diode, there are 2 diodes. There are 2 diodes. This diode is on because it is minus 10, it is a plus 1, it will make it forward bias, it will also make it forward bias. So that's why this diode is on, this diode is off. Now, if this diode is on, this is replaced by a battery. Always remember this side plus, this side minus. And it is a practical diode, 0.7 volt. And this diode will act as open circuit. This is a 1 volt battery. This is R, this is the V0. And this is what V in. So write down the KVL at this point. So you will see that V0 is equal to V in plus 0.7. Write down the 0.7 plus V in. So what is the output? V in plus 0.7 in first case. Okay. Then what is the range of the input for which this is valid? You can find by finding the current. You can find by finding the current. Now everyone, the current will in this direction because current will flow from P side to N side. So what is the value of the I? In this case, I is given by 1 minus 0.7 minus V in. Or you can directly say, I am giving you the very easy method, 1 minus V0 upon R. The same current will pass through the diode. What is the V0? Already we have calculated V in plus 0.7. Therefore, it will become 1 minus 0.7 plus V in upon what? R. Now, this will become 0.3 plus V in minus V in upon R. That is the value. This is initially it is positive, means diode is forward bias. But when this current will become negative, negative means less than 0, diode will be reverse bias. D1 will off. Now from this R is 0 and 0.3 minus V in less than or equal to 0. So what is the V in? greater than or equal to 0.3 volt. When it is just crossed the 0.3 volt, diode will be off, and that's why the first breakpoint is called 0.3 volt. Now, when the 0.3 is less than or equal to Vin is less than or equal to. Now, when we are increasing the voltage above 0.3 volt, this is off, this is also off. Both are off. Why off? Because 0.3 volt is less than 1 volt. It is reverse biased by 1 volt. And second thing, it is a practical diode. Once any diode is reverse biased and it is a practical diode, then 1.7 volt is required on the positive side. But we have only 0.3 volt. That's why both the diodes are off. When both the diodes are off, then second case, watch this diagram. This will act as open circuit. This will act as open circuit. There is no current. There is no current through this diode, this diode. So V in will not affect the V naught. And there is no current through the R. Therefore, there is no drop across the R. The output is 1. Output is 1 volt. Always remember, when the current through the R is 0, there is no drop, and therefore the output will become exactly 1 volt. This is the 1 volt. Now, up to which point it is valid? So try to understand. This is the diode D2. On this side, Vin is connected. On this side, 1 volt. V0 is connected. And what is the V0? 1 volt. This is nothing but Vn. Vn for the diode D2, and this is the Vp. So for practical diode, always remember, when Vp is greater than or equal to Vn plus 0.7, that is the cut-in voltage, then the diode will on. From this we can say, when Vin is greater than or equal to 1 plus 0.7, that is 1.7. So when the Vin is greater than 1.7 volt, means this range is valid up to what? 1.7 volt. Once the Vin is greater than or equal to 1.7 volt, this will remain off because it is reverse bias, but this diode will on because we are applying the positive voltage above 1.7 volt. Now, third case, when this diode is on, what will be the output? What will be the output in third case? Easy. Now, since this diode is on, convert it into a battery of voltage 0.7 volt. Then, tell me, what is the V0? When we are applying the KVL from this point to this point, then you will get V in minus 0.7. V in minus 0.7. Now, guys, we have the answer, right? We have the range. Now, you can plot this value. You will get the transfer curve. That is, I am going to draw the transfer curve here. First, always remember what are the breakpoints. The breakpoint is 0.3 and 1.7. So these are called the breakpoints. This is the 0.3 and this is the 0.7. 1.7. Between 0.3 and 0.7, what is this? Constant value 1 volt. This is the 1 volt. Now this is the 1 volt. When it is a 1 volt, from this point to this point, it is a constant. Before that, the equation is V in plus 0.7. So it is a Y is equal to mx plus c. Mx plus c means V naught is equal to V in is the on x axis plus 0.7. So 0.7 is the intersection with what? Intersection with y axis, and what is the slope of this line? 1. Or exactly at 0.3, what is the value? When we are putting the 0.3 here, 0.3 plus 0.7, it is the value is 1. Guys, now we have the 2 point. One, the intersection at which point? 0.7 on the y-axis. We have the value at this point, that is the 1. Draw the line, connect these 2 points. And what is the slope of this line? 1. Or when it will be 0, when the V in is minus 0.7, minus 0.7 plus 0.7, it will become 0. What is the value of the V in at this point? Minus 0.7. When the V in is greater than 1.7, what is the output? V in minus 0.7. Again, the slope is what? Slope is 1. After that, slope is 1 and interception is what? At 0.7. Draw the line with slope 1 here. And at this point, when the input is 1.7, put the value of 1.7. 1.7 minus 0.7, that is the 1 volt. It will satisfy. And what is the slope of this line? 1. When we are extending below, then it will cut at which point? Minus 0.7. But no need to extend backside. Why? Because this will start after 1.7. Which is the right answer for this question? Which one is the right answer for this question? A. A is the right answer for this question. Now guys, you can directly tell me, no need to write all the complete table and so on, because the 4 options are given. So already we have found that from 0.3 to 1.7, the answer is what? 1. Output is 1. So in which case it is 1? In this case, not. You have from 1.7 to minus 1.7 to 1.7, it is 1. This is not the case, and that is the case. Only one case will satisfy. From 0.3 to 1.7, it is what? 1. Second important thing about this question, you can assume let both the diodes are off initially, and you will get the range. When both the diodes are off, you can directly take, let both the diodes are off. This is 1 volt, this is R, this is the V0, and V0 will become 1. Directly you can say there is no current, D1 and D2. Now compare. When this diode will on, for what value of the diode will on, for what value of diode will on. Okay. Now what is the voltage at this point? 1 volt. Now this diode will on. Here always remember, this is the Vn, 0.7 drop is required, and this is the Vp. What is the value of the Vp? 1 volt. What is the value of the Vn? Vi. Because this side Vi is connected. Okay, always remember Vp should be greater than or equal to Vn plus 0.7. What is the Vn? Vn should be less than or equal to Vp minus 0.7. It will become Vin minus 0.7 volt. So Vp minus 0.7. So what is the value? Sorry, what is the value of the Vp here? 1 volt. Vp is given as 1 volt. This is the Vp. 1 volt. So it should be less than 0.3 volt. When we can say when the input is less than 0.3 volt, this diode is on, right? And then from that condition we can find what is the output. Similarly, when this diode will on, this diode is on. This is the on Vp side, Vin is connected. On V0 side, 1 volt is connected, 0.7 is required. So Vp means Vin should be greater than or equal to 0.7 plus Vn plus 1. Means when it is greater than 1.7 volt, then D2 will on. So you will get the range from 0.3 is less than Vi is less than 1.7, both the diodes are off. When both the diodes are off, the output is exactly equal to 1. So from this you can find, and then you can give the answer directly. This is the answer. From 0.3 to 1.7, both the diodes are off and we are getting the 1. After that, D2 on. After below that, D1 is on. This is all about this question. Next one. One minute. Okay. Already we have discussed this question. That is now. This was the question on what? Hybrid parameters. But there is some problem. The H parameters of a two-port network are shown below. When we are saying that H parameters is what? Standard parameter, like what? Z parameter, like what? Y parameters, Z parameter, Y parameter, H parameters, ABCD parameter. These are the standard, right? So when we are saying that H parameter means what? We have the equation V1 is equal to H11 I1 plus H12 V2. This is the standard equation. And what is the I2 is equal to? I2 is equal to H21 I1 plus H22 V2. Okay. The dimension of H11 is what? Ohm. V1 by I1. Dimension of H12 dimensionless. H21 dimensionless. Both are dimensionless. Unitless. And what is the H22? Mho. Right. H22 is mho. And here, what is the model? This model is correct. H11 is the resistance ohm. This is also correct. We have to connect what? H12 V2. This is also correct. This side it is correct. But when we are dividing the current, in this place, what is required? H21 times of I1 is required. H21 times of I1 is required plus H22 V2. That is correct. But here, what is given in the question? H12 V1 is given. H12 V1 is given, and that means model not matched with this line, and that's why we can't give the answer. Therefore, it is a empty. Marks to all. So guys, remember, if during exam, if you are not comfortable with any question, then simply leave it. We can give it for what? MTA and so on. So normally we are wasting our time. Right, but every question is not empty. Read the question carefully. If there is some discrepancy or you are not able to solve the question, then simply leave it. First of all, solve all other questions and then go for it. Okay, this type of questions. Number of students have wasted the time there. Next one. Now, that is the next question on current mirror circuit. What is the very easy question? In the circuit below, the voltage VL is VL. Where is the VL is found? Across the 1 kilo ohm resistor. This is called VL. VL. Now you have to find the current. What is the current here? IL. Then we can find the VL. IL into 1 kilo ohm. VL will become IL into 1 kilo ohm. Right. This is the first equation. Now this is a current mirror. It will make a current mirror with this transistor. Like this is the number 1. It will make the current mirror with number 2, MOSFET. Now, it will also make a current mirror with number 3. So, 2 and 3 are current mirror circuit. 1, 2 and 3 are the part of the current mirror. And these are the images. Now, what is the ratio? For example, I am giving this current. This current is I1. I1 is 1 milliampere. What will be the I2? And what will be the I3? Now, I2 by I1 is nothing but W by L of 2 upon W by L of 1. This is called aspect ratio. So, what is this? 10 by 1. And that's why I2 will become 10 times of I1. That is nothing but 10 milliampere. Similarly, I3 by I1, it is W by L of 3. W by L of 1, that is 7 by 1, and that's why I3 will become 7 times of I1, that is nothing but 7 milliampere. This current is 7 milliampere. This current is 10 milliampere. Now this MOSFET 2 and I give the name like this is the fourth one. 2 and 4 are connected in series, and 3 and 5. This is the 3 and this is the 5. Like it is the 5. When the 2 and 4 are connected in series, the same 10 milliampere will pass through this transistor, because what is the input impedance of the gate terminal? Infinite, sorry. Input impedance of the gate terminal is infinite. That's why what is the gate current? 0. Same 10 milliampere current will pass through the fourth one. This is the 10 milliampere. Now the 4 and 5 are what? Current mirror circuit. So with the 4 and 5 are current mirror circuit, then what is the I5 by I4 is equal to W by L of 5, W by L of 4. I5 is equal to, this is nothing but 10 milliampere. And what is the W by L5? Remember that this is the 5, this is the 5, and that is the 10. This is the 5 and that is the 10. 5 divided by 10 into I4. 5 divided by 10 into 10, and that's why it will become 5 milliampere. Only the half current will flow because the aspect ratio is half of that. Same 10 milliampere flow, here 5 milliampere flow. What is the current in the MOSFET number 3? 7. Now here the current is 7. 7 out of 7, 5 will pass through this. So what is the current IL? IL will become 2. 7 minus 5, it will become 2. So once you will get the value of the IL, 2 into 1, so VL will become 2 volt. 2 into 1, that is the 2 volt is the answer for this question. 2 volt is the answer for this particular question. Okay, then next one. So this is the question from analog and EDC, guys. Now Asu Jangra sir will continue with network. Then thank you for attending the session. You are on BYJU'S exam prep. Thank you.
Thank you, Rathi sir. And guys, from this point onward, we'll discuss about network theory. So this is question number 25. In this question, a series RLC network is given to us, and the quality factor is given as 1000, and the center frequency means resonance frequency is 10⁶ radian per second. The possible value of R, L and C are. So now what you can do is, we know that in a series RLC network, let's say you have a series RLC network. So in a series RLC network, the quality factor Q will be 1 by R root L by C. Okay. And this value is provided as 1000. And the resonance frequency is 1 by root LC. And this value is 10⁶. Okay. Now we need to calculate the value of R, L and C. You can use the options also, but there is one more way. From this quality factor and resonance frequency, we can calculate the bandwidth. We know that the bandwidth is, there is a formula of quality factor, that is resonance frequency divided by bandwidth. So bandwidth will be resonance frequency divided by the quality factor Q. So it came out to be 10⁻³ and bandwidth is equal to R by L. So R by L value has to be 1000. Now we know this equation, we know this quality factor. So what I can do is using these relations, and so there are three equations. One, this is my second number relation and this is my third number relation. We can calculate the value of RLC because there are three unknowns and three equations. So if you want to calculate RLC, what you can do is, let's first try to calculate the value of, what you can do is, we can divide this with this, okay? Or there is one more way, and that way is better we multiply them, no? So let's multiply equation number 1 and 2. So if you multiply, you will get 1 by R, 1 by RC. 1 by RC is equal to 10⁹, okay? 1 by RC equal to 10⁹. Now, from this relation, if you want to calculate again L and C, so you can use the options also. Now you can use the options also. In which option this product is 9 and this product is, this relation is 1000, this relation is this and this relation is this. So you can check using the options, okay? So now if you use the options, then you can see that if you select option number D, if you take option number D, okay, if you use D option, then this D option satisfy all these conditions. If you put L and C value, you will get the same thing, because in all the options L and C are the same, okay? So using L and C you can't judge, but if you use this L and C along with the R, okay, so you can use this option, na? R by L. So R is this and L is this, so you will get 1000. So only this option satisfies the answer. The answer is ready, okay? So this was 1 mark question. Let's come to the next question. In the circuit shown below, the switch S was closed for long time, okay? It was closed for long time, and at t equal to 0 it is open. The maximum magnitude of the voltage VR. We need to calculate the maximum voltage across the resistance. So what I can do is, the switch was closed for long time. It means this inductor was under steady state, so it is sorted. It means this will also be sorted because this is connected in parallel. So the current will be 2 divided by 1. 2 divided by 1 means 2 ampere, okay? So 2 ampere current was flowing like this. I hope it is clear. Now you have opened this. If you have opened this, then the circuit will look like this. We have one resistor and there is a resistor and an inductor. Now this inductor will keep on, this will keep this current, okay, this will keep flowing this current, and this is open now. So you can say that this the initial current is 2 ampere, and this 2 ampere will try to flow via this path, okay, and this is 2 ohm. So the voltage across this 2 ohm will be 4 volt, okay, and opposite polarity is asked, okay. So this polarity VR has to be -4. It means the maximum voltage across this resistor has to be -4, but in magnitude it is asked, the maximum magnitude. So magnitude is 4 volt only, okay. I hope it is clear. So it's a simple question. Now, and why it is maximum? Because after that, after some time, it will keep on decreasing. The current will keep on decreasing exponentially. The current will decrease and the voltage will also decrease. So at t equal to 0 plus only, you will get the maximum voltage, okay. Let's come to the next question. Question number 27, again from network theory. Now in this question, we need to calculate this current I, okay. I flowing through this 200 ohm, okay. So what I can do is, let's first apply the source conversion rule. If I apply the source conversion rule here, you can see that there is a current source of 1 milliampere in parallel with 2 ohm. So the circuit will look like this. There is a current source of 1 milliampere, and in parallel we have a resistance of 2 kilo ohm, okay. So I have converted this voltage source into current source, and there is one more 2 kilo ohm in parallel. There is one more 2 kilo ohm in parallel, okay, this 2 kilo ohm, and there is a one more 1 milliampere current in parallel, okay, 1 milliampere current in parallel. Now this circuit can also be, this source can also be converted into voltage source. You can apply the source conversion. So here you have the resistance of 1 kilo ohm, and in series with a voltage source of 1 volt, and there is a resistance of 200 ohm, okay. There is a resistance of 200 ohm. I hope it is clear, guys, okay. And this current is I. So what I need to do is, I need to calculate this current I. So it's very simple. You can see that this 1 milliampere and 1 milliampere are in parallel, so it will become 2 milliampere, and this 2 kilo ohm and 2 kilo ohm are again in parallel, so it will become 1 kilo ohm. So what I can do is, I can replace this circuit with this current source of 2 milliampere, and in parallel we have a resistance of 1 kilo ohm, okay. And now there is one more resistance here, 1 kilo ohm, and there is a voltage source of 1 volt, and here you have 200 ohm, okay. Here you have 200 ohm, and this is my current I, okay. Now again you can apply source conversion here. So this 1 kilo ohm will be in series, and this 2 volt will also appear, okay. So what you can do is, you can erase this side, let's remove it, and now you can connect 1 kilo ohm here in series with 2 volt, okay. So this is the circuit now, and now you can calculate the value of this current I. So I will be equal to 3 volt. This is the total loop voltage in this loop, 3 volt, divided by the total resistance, 1000 plus 1000 plus 200. So it will be 2200. So the answer came out to be, let me check the answer. Answer came out to be 1.36, I suppose, 1.36 milliampere, okay. So in milliampere is asked, 1.36, okay. Let's come to the next question, guys. So in this question, again, a Y parameter of the network are given. The Y parameters of this network are given, and we need to find the value of ZL for which the maximum power can be transferred, okay. So what I can do is, let's assume that this is my V1, this is I1, this is V2, and this is I2. What I need to do is, I need to calculate the Thevenin impedance, okay. So to calculate the Thevenin impedance, just sort it. There is no need for this voltage source, and here you can connect a 1 ampere current source, and try to find the voltage across this 1 ampere current source. That voltage divided by the current. This voltage, voltage across this is V2. V2 divided by 1 will be my RTH, and that RTH will be equal to the ZL value, okay. So we need to calculate Thevenin impedance, okay. So what I have done is, I have sorted this and I replaced with the 1 ampere current source, and I need to calculate this voltage. So what I will do is, let's write the equation of this Y parameter. So the equation for the Y parameter is equal to, I1 is equal to Y11, that is 2 by 100 V1 minus 1 by 100 V2, okay. Similarly, I2 will be equal to minus 1 by 100 V1 plus 4 by 300 V2. Okay. So we have written the Y parameter equation. Now in this equation, we need to calculate V2. But before calculating V2, we know that I2 has to be 1 ampere. So what you can do is you can replace I2 with 1 ampere. Now you have to look at the external connection. I2 as 1 ampere and V1 is minus 10 I1. This is sorted, na? So V1 is minus 10 I1. You can see that. Okay. V1 has to be minus 10 I1. So V1 can be replaced with minus 10 I1. So what I can do is I can replace V1 with minus 10 I1. Minus 10 I1 and here also minus 10 I1. Okay. So this way you can replace it. Now from this equation, you can solve for, you can calculate the relation between I1 and V2 and you can use that relation in this equation to calculate V2. How to use that? This 0 is cancelled. So you can see that you can take this I1 on this side. So the coefficient of I1 will be 1 plus 2 by 10. 1 plus 2 by 10 and that is equal to minus 1 by 100 V2. Okay. Is it clear, guys? The coefficient of I1 is 2 by 10. Okay. 1 plus 2 by 10. This is equal to minus 1 by 100 V2. So it will be I1 into 12 by 10 is equal to minus 1 by 100 V2. So we have calculated I1 in terms of V2. So let's further proceed it. This 0 is cancelled. So you will get minus 1 by 120 V2. Okay. So we get I1 in terms of V2. Now we can put this value of I1 and this will also be cancelled. This 0 will also be cancelled. So now I1 will be equal to, if you look at this equation, if you look at the equation number 2, 1 is equal to, this will be 1 by 10 I1. Okay. Because it is negative, it is also negative. So it will become positive. 1 by 10 I1 and I1 can be replaced with minus 1 by 120 V2. Okay. Plus 4 by 300 into V2. I hope it is clear. So from this relation, you can calculate the value of V2. So let's try to simplify this. So now you can say that I can simplify this relation and 1 is equal to, take the LCM. LCM will be 1200. LCM will be 1200, you can see. So at this place you will have minus 1 plus at this place you will have 16, okay, into V2. So from there V2 will be equal to, tell me guys, V2 will be equal to 1200 upon 15. 1200 upon 15, okay, and 1200 upon 15 you can cancel this with 5, so 3 and okay, and then 80. Okay, so V2 came out to be 80. So this voltage came out to be 80. So the RTH will be equal to 80 upon 1, that is 80 ohm. So the answer is 80 ohm. I hope it is clear. So this way you can solve this question. You should know how to calculate the Thevenin impedance in when the two-port networks or two-port parameters are given. So you can apply the same method and calculate this question. Let's come to the next question, guys. So this question is MCQ and it's a 2-mark question. In this question, it is given that the switch S1 was closed and S2 was open. So it was closed and it was open for a long time. Okay. It means this circuit is working under steady state. If it is working under steady state, then the inductor will behave like sorted, capacitor will behave like open circuited. So the circuit is like this for t less than 0. Okay. For t less than 0, I am writing. At t less than 0, this circuit is under steady state and the capacitor is behaving like open circuit. And the inductor is behaving like this switch was open. So this 100 ohm was in circuit and this inductor was sorted. Okay. And there is one more resistance as 25 ohm. Now you can see that this current will be divided. Now how much current will flow here in this inductor? So the current, you can apply the current division rule, 1 into 25 divided by total 125. Okay. So it will be 1 by 5 ampere. So this current is 1 by 5 ampere and this voltage across this 100 ohm is 20 volt. So this voltage is 20 volt. It means this capacitor is charged at 20 volt. This capacitor is charged at 20 volt. So we get an idea that this is charged at 20 volt and the current is 1 by 5 ampere. Now what he did is he opened this switch and he closed this switch. So now the new circuit will be at t equal to 0 plus, the new circuit will be, this capacitor will behave like voltage source at t equal to 0 plus. This capacitor will behave like voltage source and the voltage will be 20 volt. Okay. On this side, the current source is removed. On this side, this resistance is also sorted via this switch. Okay. So only inductor will be there and the inductor current is 1 by 5 ampere. Okay. 1 by 5 ampere and there is one more resistor here and the resistor value is 25 ohm. Okay. This is my 25 ohm. Now you can see that this current will be, because this 20 volt will be in parallel with this resistance. So you can say that 20 divided by 25. So 4 by 5 ampere will flow like this. And 1 by 5 ampere is going like this. So the total current has to be 1 ampere. So this current in upward direction is 1 ampere at t equal to 0 plus. But the question asked is downward current at t equal to 0 plus. So the downward current at t equal to 0 plus is -1. Okay. So the answer has to be Bombay. Okay. Let's come to the next question, guys. Now the control system is started. So we have completed network theory. Now let's start with the control system. In this question, open loop transfer function of a unity negative feedback system is provided to us. Okay. The value of K, T1 and T2 are positive constant, the phase crossover frequency. We need to calculate the phase crossover frequency. So it's very simple. Phase crossover frequency, you have to calculate the phase and you have to equate it to -180. Okay. So the phase of this quantity, because feedback is unity. So actually the phase of GSHS is required, but HS is already 1. Na? So what you can do is you can check the phase of GS only because HS is 1. So you can replace S with j omega and try to calculate the phase. So the phase of this quantity will be -90 because I have changed S with j omega. So the phase of j omega is 90. You come to the numerator, it will become -90 minus 10 inverse of omega T1 minus 10 inverse of omega T2. Okay. So this is the phase. This is the phase of this function and it has to be -180. To calculate the phase crossover, it has to be -180. Now you can see that if I can simplify this, 10 inverse of omega T1 plus 10 inverse of omega T2 has to be equal to 90. Okay. Now if you can simplify this, it will become 10 inverse of omega T1 plus omega T2 divided by 1 minus omega square T1 T2 and it has to be 90. This will be 90 only if this denominator becomes 0. It means omega has to be equal to 1 by root T1 T2. Okay. So this is my phase crossover frequency. So it was 1 mark question and answer is Agra. Okay. Let's come to the next question, guys. So the next question on your screen is a closed loop system is shown in the figure for K greater than 0 and alpha is also greater than 0. So this is my ramp function. It's not RT, it's alpha RT. Okay. Alpha RT and the Laplace is alpha by S square. Okay. The steady state error due to ramp input will be equal to. So we need to calculate the steady state error. We know that the steady state error due to ramp input is equal to 1 over kV, velocity error constant. But it is due to units ramp input. But actually the ramp input is alpha times. So you have to multiply this with alpha. Okay. You have to multiply this with alpha. Okay. Now we need to calculate kV. kV will be equal to limit S tends to 0 S GSHS. Okay. Now we know that this is my GS, HS is 1. So S into K divided by S into S plus 2 and limit S tends to 0 you have to apply. Limit S tends to 0. This S is cancelled, so it will become K by 2. So kV is equal to K by 2. So you can put the value of kV. So ET steady state will be equal to 2 alpha by K. Okay. So the answer is Agra again. I hope it is clear. Let's move to the next question, guys. Now the question number 32 you can see. In this question, the following block diagram, RS and DS are the input. Then the output YS is expressed as YS equal to Z1 RS plus Z2 DS. The value of Z1 Z2 will be equal to. Okay. So we need to calculate the value of Z1 Z2. Now you can see that this is the block diagram. Now better you convert this block diagram into SFG. Okay. So this is one node, this is one node, this is one node. Okay. So if you can convert this, this will be my G. Okay. This will be my G. And here you have H. Here you have minus H. Okay. And here you have 1. Here you have 1. Okay. and at this node you have again -1. Okay, from this point you have -1. Okay, this is -1, and this is 1 RS. Okay, this is 1 RS, and at this point you have DS. Okay, and now this point 1, and this is YS. Okay, so it's easy peasy. Now this is the block diagram, this is the signal flow graph which we can use. So now let's first calculate the output due to RS. Okay, the output due to RS. Let's first calculate this G1S. So you can put DS equal to 0. So if you put DS equal to 0, then only one forward path is there. Only one forward path is there, M1. So M1 is equal to Z. Okay, and there is only one forward path. Now the delta will be equal to 1 minus individual loop gain. So this is minus GH. Okay, and this is minus G. Okay, this is minus G. These are the individual loop gain, plus 2 non-touching loop gain. There are no non-touching loops, so it's 0. Now delta 1 is 1 minus those individual loops which are non-touching to first forward path. There are no such loops. Okay, so now you can calculate the transfer function as Z divided by M1 delta 1 divided by delta 1 plus GH plus G. Okay, this is my G1S. Okay, so G1S has to be this. Now in which option it is given? In A option it is given. Okay, and this is wrong, this is wrong. Now look at this option again, A, B. This has to be B, this has to be C, and this has to be D. Okay, now if you look at this option again, in this option it is given. Okay, GS is like this only. Now let's come to YS over DS. Okay, now how to calculate YS over DS? It means G2S we need to calculate. So we know that the delta will remain same, delta will not change. It means the denominator will remain same, only the numerator will remain will change. And the forward path gain for this function is, tell me, if you make this 0, if you are making this 0 and you are putting the input here and you are calculating, this is input, this is output, you are calculating the transfer function. So the forward path gain M1 is equal to only G. Okay, only G, and delta will be equal, delta 1 equal to 1. And delta will remain same because the circuit is same, the flow graph is same, so delta will remain same. So it means M1 delta 1 divided by delta. Okay, so I think answer is Agra because the denominator has to be same. So you can see that answer is Agra. Okay, so this was again very simple question. I hope everyone has done this. Now let's come to the next question. This is again a very good question. So actually we are provided with the state equation, x dot t equal to axt. Now if you want to solve this question, you can apply the mathematics, and let's say the eigenvalue of A, there are two eigenvalues, no? Lambda 1 and lambda 2. Lambda 1 and lambda 2. And for lambda 1, the corresponding eigenvector is, let's say, V1. And for lambda 2, the corresponding eigenvector is, let's say, V2. So what we can do is we can write the solution of this equation. And the solution of this equation is xt will be equal to some constant C1 e to the power lambda 1 t into V1. Okay, plus C2 e to the power lambda 2 t into V2. You using mathematics you can prove this. Okay, so this is the solution of this equation. Now this is written only in this A option. You can see that if you can open it, then you will understand that alpha is replaced with this C1 C2. No? Okay, and I have solved this, I have written this in many marathon sessions also. I have taken some questions on this this part also. So this is a very simple question, and this was for 2 marks, and answer is Agra. Okay, let's come to the next question, guys. In this question, the asymptotic magnitude plot of a minimum phase system is shown in the figure. The transfer function of the system is, so we are provided with the transfer function. Okay, this is my, let's say, GS, and the Bode plot is also given as like this. We need to calculate the sum of these powers. So tell me, guys, this is minus 20 dB per decade. The first line is minus 20 dB per decade. It means B has to be 1. Okay, B has to be 1. If in the denominator, if you have 1 by S, then the first line has to be minus 20 dB per decade. At omega 1, you can see that the slope is increased. It means the omega 1 has to be in the numerator. Okay, and in the numerator there are zeros, and only minus 20 dB has changed to 0 dB. It means 20 dB per decade is increased. 20 dB per decade means it has to be single power. So A has to be 1. Okay, Now look at this point. At this point, the slope is changed with minus 40. I mean, from 0 to minus 40. It is decreased. So it should be in the denominator. So this quantity is in the denominator. And the slope has changed from 0 to minus 40. It means double of 20. Double of 20 is 40, na? So this power has to be 2. Okay. So C has to be 2. Now, if you sum these two values, then you will get 2 plus 1 plus 1. That answer is 4. Okay. So you'll get 4 answer. Now, let's come to the next question, guys. So this question is from electromagnetics. Okay. And from this point onward, Saket sir will carry. Okay. I hope you have understood this control system and network question. So that's all for control and network. From now onward, Saket sir will continue. Thank you.
So thank you Ashu sir for giving the solution of the subjects. Now I will be going to discuss about the electromagnetic theory. So you can see that there are good questions coming from this subject. Generally this subject was avoided in the previous year because the questions were easy. But now this time they have asked the question, very excellent question from the subject. So let's begin with the solution. So the first question is, consider a narrowband signal propagating in a lossless dielectric medium, epsilon r is equal to 4, mu r equal to 1, with phase velocity Vp and group velocity Vg. Which of the following statement is true? Vp greater than C, Vg greater than C, Vp less than C, Vg greater than C, and Vp greater than C, Vg less than C, and both Vp and Vg less than C. So first of all, you have to understand what is the relationship between the group velocity and the phase velocity. So if I write the group velocity, then it is del omega by del beta. Okay, this is the definition of group velocity. And if I write the relation of the phase velocity, then it is nothing but a omega by beta. Okay, so suppose I calculate the delta upon delta omega of beta, then what is the value of beta? Beta is given by del omega of omega by Vp. Generally we write the beta as omega by Vp. So if I differentiate it with respect to omega, so if I take this 1 upon Vp common, right, then differentiation of omega will be 1. And then if I take this omega common, then we will have del Vp upon del omega. So we will get this relationship. Yes, one more thing, that because we are differentiating the Vp, so this 1 upon Vp is the minus 1 upon V square. So this is why I have written minus sign, and this is Vp square. So this is the del beta upon del omega. Now if I write the Vg, then what will be this value Vg? So this Vg here, if I again invert it, so for this I have to write in this way. This is 1 upon, this is your 1 divided by 1 by Vp minus omega by Vp square del Vp upon del omega is equal to del omega by del beta, which is Vg. So this is the group velocity. Okay, so this is the relation of the group velocity. Again, I am writing Vg is equal to, if you will take 1 upon Vp common, then according to that also you can write this is Vp. If I write 1 upon Vp common, then it is in the numerator. So this is 1 minus omega by Vp and del Vp upon del omega. So this is the relation we will get for the group velocity. Now according to the question, it is given that the lossless dielectric medium. So for lossless dielectric medium, what is the condition? The lossless dielectric medium means Vp is equal to simply omega by beta. Okay, and beta is equal to omega root mu epsilon. So this omega and omega will get cancelled, so we will get 1 upon root over mu epsilon, right? So you can see that this Vp is independent of frequency. This Vp is independent of frequency. What does it mean? If you will differentiate with respect to omega, it will be 0. Okay, so it means that we will have, for lossless dielectric, this del Vp upon del omega equal to 0. So you can see that Vp is equal to 1 upon root over mu epsilon, and what is the value of Vg then? From here we have Vg is equal to Vp. Now it is proved that the group velocity and the phase velocity will be same. Now the question arises that whether it is a less than c or greater than c. Then how can you calculate the relation with the speed of light? So this is Vp is equal to c upon root over mu naught into epsilon mu r into epsilon r, right? This mu and epsilon naught, I will put the value of mu and epsilon. So this is mu naught mu r and epsilon naught epsilon r. So the 1 upon root over mu naught epsilon naught is velocity of light. So from here we will get 3 into 10 raised to power 8 divided by root over epsilon r is 4 and mu r is 1. So from here you will get 1.5 into 10 to the power 8, which is obviously less than the velocity of light. So now it is proved that the Vp is less than velocity of light, and because Vp and Vg are same, we have proved for lossless medium, then what is the answer? Both will be less than velocity of light. So both will be less than velocity of light. That is the correct answer, option D. Okay, that is your correct answer, option D. Now coming to the next question. This is the next question we have. This is a question from the S parameter. The S parameter of a two network is given as S is equal to S11, S12, S21, S22 with reference to the Z0. The two lossless transmission line sections of electrical length theta 1 is equal to beta L1 and theta 2 is equal to beta L2 are added to input and output port for measurement purpose respectively. The S parameter S dash of the resultant two-port network. So whenever you add the transmission line in any port of certain length, so we have a two-port network and we have added one extra transmission line of length L1. Okay, so in that case, this is the property of your S parameter. So from the property of S parameter, we will write S11 is equal to S11 e to the power minus j theta I. Actually, we should write like this. S11 dash is equal to S11 e to the power minus j theta 1 multiplied with 2. This is the property, okay? This is the property. You can learn it from any microwave book, or you will get in some textbook also. So because this is the input side, we have the angle theta 1. If I is equal to j, okay, if I equal to j, where I is varying from 1 to 2. Now second one is Sij dash is Sij e to the power minus j theta I plus theta j, or the angle is theta 1 theta 2, so should we write theta 1 theta 2 only? That would be better. So let's write theta 1 and theta 2 here. Okay, so this is when I is not equal to j and I is varying from 1 and 2, because there are two ports, so I is 1 and 2. So if I write from the first equation, this S11 dash, this S11 dash is equal to S11 and I equal to 1 I have substituted, so e to the power minus j 2 theta 1. If I write I and j is not equal to, that means S12, I and j not equal, so when I put I equal to 1, then j should be 2, it is not equal. So this is S12 e to the power minus j theta 1 plus theta 2. If I put S21, which is again I is not equal to j, so this is S21 e to the power minus j theta 1 plus theta 2. And again, if I is equal to j, That is, if I put I equal to 1, I have taken, I put S22, then S22 e to the power minus j theta 2. If I put second port, then I have to take the second angle. In that way you have to write. Okay, so if you will see this, according to that, our answer is option A. Option A is our right answer for this question. So if you are adding an additional port or length transmission line in the second port, then the angle of the second port will be involved, and if you add in the first port, then first port angle will be involved if it is only input or output port. That means I is equal to j, and if I is not equal to j, then the both angles are involved, that is theta 1 and theta 2 both. Now coming to the next question. Yes, so we have this question. The standing wave ratio on a 50 ohm lossless transmission line terminated in an unknown load impedance is found to be 2. So the VSWR is 2. The distance between the two successive voltage minima is 30 centimeter, and the first minima is located at 10 centimeter away from the load. ZL can be replaced by the length LM and terminated resistance RM of the same line. What should be the value of RM and LM? So this question is MSQ question. We have more than one answer correct for this. This is the first case when the transmission line has the ZL length. The effect it produces, equivalently we are replacing this load by some extra length of transmission line which is also producing the same effect which the first diagram is producing. That means the length is LM and the resistance RM will produce the same effect which this ZL alone is producing, that is voltage minima it is giving, and the VSWR it is giving as 2, etc. So if you are replacing, if I found this ZL, if I find this ZL, then according to this ZL, the effect of ZL will be replaced here as a input impedance, because this ZL will be act as an input impedance for this transmission line. You can see this dotted line also. This is the simple representation. We are putting one extra transmission line of length LM and the resistance RM, but this and this will produce the same thing that is given in the question. So this load will become input impedance for this extra length transmission line. So if I want to replace it equivalently, then this complete transmission line will be replaced by input impedance. And what should be the input impedance? The input impedance will be the load impedance of the first case, correct? How do we replace actually any transmission line characteristics? When we draw the equivalent circuit, then we replace it by its input impedance. So the input impedance of this transmission line will become the load impedance of the first case. So what is the load impedance of the first case? Let's first calculate, because it is given that the, if I go into the next slide, suppose, because I need one, okay, let's write the gamma. Mod gamma can be calculated as S minus 1 divided by S plus 1. So it is 2. So 2 minus 1 upon 2 plus 1, which is equal to 1 by 3. So 1 by 3 is the standing reflection coefficient we are getting. That is only magnitude. We need a phase also. Okay. So now next thing is what is given here? The distance between the successive voltage minima is, so the distance between the successive voltage minima is lambda by 2. So lambda by 2 is equal to 30. So here the lambda is 60 centimeter. So the second value which we have calculated, the minimum is given as 30. So we know that the distance between two successive minima is lambda by 2. So we are getting lambda is equal to 60. Now we need a minimal distance is also given, that is the first minima we are getting a 10 centimeter. So what will be the value here? Okay, so now what we want to calculate? We want to calculate the minima. How do we calculate the minima? So 2 beta into z minimum. Okay, 2 beta into z minimum minus theta r should be odd multiple of pi. Okay, theta r is the angle of reflection coefficient. So if I substitute all the values, like lambda we have already calculated. Okay, for the first minima, okay, for first minima, the n equal to 0, the theta r we want to calculate. So this theta r is equal to 2 beta z minimum and minus pi. So 2 into beta is 2 pi by lambda, the lambda we have calculated, into z minimum minus pi. So 2 pi into, in fact 2 divided by lambda, lambda was 60 and the minimum is 10. So minus pi. So we have got, this will get cancelled and we will get 2 pi by 3 and 2 pi by 3 minus pi, that is equal to minus pi by 3. So the theta r we have got, that means the reflection coefficient magnitude and phase both we have calculated. So the reflection coefficient is magnitude and e to the power j theta r, and this is your 1 by 3, and e to the power phase is negative, so minus j pi by 3. So this is how you have calculated the magnitude and phase of reflection coefficient. Now our next part is, because we know our aim is to calculate the load impedance, so the next part is the reflection coefficient is ZL minus Z0 divided by ZL plus Z0. Okay, so what is the value of ZL? We want to calculate. What is the characteristic impedance? 50 it is given. Okay, so ZL plus 50. What is the reflection coefficient? We have calculated 1 upon 3 e to the power minus j pi by 3 is equal to ZL minus 50 divided by ZL plus 50. So if you want to calculate in terms of this, then it can also be written as 1 plus 1 by 3 e to the power minus j pi by 3 divided by 1 minus 1 by 3 e to the power minus j pi by 3. Okay, so it is your work to calculate. Yes, one more thing, that Z0 we have not written. So this is Z0, which is 50. Okay, so now after this, if you will calculate, I am writing the direct value. It is coming as 67.97 e to the power, or simply angle is minus 32.67. 67.97 at an angle minus 32.967, sorry, 67. So this is how you will calculate the load impedance. Now, as I told you that this load impedance will become the input impedance in the second case. So what is the input impedance? So the input impedance can be written as, input impedance for a lossless line is Z0 ZL plus JZ0 10 beta L, right, divided by Z0 plus JZL 10 beta L. This is the formula. So here our characteristic impedance is fixed. The load impedance will become resistance Rm, and J into Z0, the length of the transmission line will be Lm. Okay, divided by Z0 plus J into Rm 10 beta Lm. Okay, so this input impedance should be equal to the load impedance. so this input impedance should be equal to the load impedance, which is equal to this Z0 and Rm plus J Z0 10 beta Lm divided by Z0 plus J Rm 10 beta Lm. Now this left hand side we know, the right hand side the characteristic impedance we know, so which was the value 67.97 and at an angle 32.67 with minus sign equal to 50, and the resistance Rm we want to calculate plus J into 50 10 beta into Lm divided by 50 plus J Rm 10 beta into Lm. Now by option, when you will go and substitute the value, you will see that only option B and C are satisfying this equivalence. Okay, you put the value of Rm from the option, you put the value of Lm, you will calculate the beta Lm, right? Beta Lm you can calculate, this is 2 pi by lambda, lambda was 60 and the length is given in the option, and all the options are given in the centimeter. Like if I take the option A, the option A is having the Rm is equal to 100 and Lm is equal to 20 centimeters. So if you will calculate the beta Lm, then it is 2 pi upon 60 into 20. So this is nothing but it 2 pi by 3. Okay, so 2 pi by 3, substitute the 10 2 pi by 3 and put the value of Rm, which is 100, and calculate its value. Its value should be equivalent to this one. It will be close to that. If you will not get exact value, then don't worry. Suppose you are getting 68.12 something or 66.66 something, then also it is okay. It should be very close to each other because it is something where we are approximating the values. Beta Lm will be giving you some value, you will approximate it. Here also we have calculation is done after some approximation, basic numerical approximation. So maybe there will be not very much variation, like if it is 67 and you will get 70, don't it will not be having that much variation, but this 67 can have the 68 or 66 also. This 32 can have the 31 and 33, 32.8 like that also. That can be considerable, and according to that, if you go and check all the options, B and C will be the only options that is correct. Okay, so in this way you have to solve the question. Now coming to the next question. So the next question says the electric field, this is about the polarization. The electric field of a plane electromagnetic wave is E is equal to AX C1x cos omega t minus beta z. This is Z, that is the direction of propagation, plus AY C1y cos omega t minus beta z plus theta. Which of the following combinations will give rise to the left hand elliptically polarized? So for the linear polarization, the phase must be integer multiple of pi. For the circular polarization, the phase must be integer multiple of pi by 2 along with the amplitude equal. And for any other random phase, we have the elliptical polarization, whether amplitude is equal or not. So you should remember that if you can see the options, this is the first option, you can see the amplitudes are equal. So if you see the amplitudes are equal, we generally think that it may be the circular polarization, because in the circular polarization the amplitude should be equal. But along with that, the phase should also be the odd multiple of pi by 2. So but it is not odd multiple of pi by 2, it is pi by 4. So that is why it is not a elliptical circular polarization. And in all the other cases, the phase is random. Okay, the phase is either odd multiple of pi by 2 or it is some random phase. So in that case, it is elliptical polarization. So all the options are showing the elliptical polarization. Just we have to check whether it is a left hand or it is a right hand. So let me add some extra slide. Okay. So this is first of all, what is the polarization? The polarization is nothing but the trace of tip of electric field, at any point in space as a function of time in the plane perpendicular to the plane of direction of propagation. So okay, so what we will say, the polarization is nothing but a trace of tip of electric field in the direction in the plane perpendicular to the direction of plane at a space, that means at a specific point of space as a function of time. So first of all, as a specific point in the space means we will take z is equal to 0. So at z is equal to 0, okay, if I take at z is equal to 0, this equation of electric field will become, ax c1x cos of omega t plus ay c1y cos of omega t plus theta. Okay, so that is the specific point in space. As a function of time, we need to plot the tip of electric field. So how do you draw the electric field? According to the first option, if I go through the first option, okay, so from the option A, the option A says C1x is equal to 1 and C1y is equal to 1 and theta is equal to pi by 4. So what will be the equation of electric field? It will be ax cos of omega t plus ay cos of omega t plus pi by 4. Now at t is equal to 0, if I want to calculate the electric field, then it is E is equal to cos 0 will become 1, that is ax, and cos pi by 4 will become 1 by root 2. Okay, and at t is equal to t by 4, we will get electric field omega t will become 2 pi by t into t by 4. This omega small t will become pi by 2. So pi by 2, cos pi by 2 is 0. So that is 0 into ax. And this is omega t, pi by 2 plus pi by 4. So what is the pi by 2 plus pi by 4? The pi by 2 plus pi by 4, we will get 3 pi by 4, and the value is minus 1 upon root 2 ay. Okay, so this will be the electric field. Now we will draw it in the xy plane. Why we are taking xy plane? Because the direction of propagation is z. So I said that the polarization we calculate in the plane perpendicular to the direction of propagation. So the direction of propagation is z. So the plane which is perpendicular to the z is xy. So we will draw in the xy. So at t equal to 0, if I draw, at t is equal to 0, if I draw, it is in the x-axis it is 1 and it is the 1 by root 2 in this point. So this is magnitude 1 and here it is 1 upon root 2. This is the first point. Okay, and the second point is saying x is 0, y is minus 1 by root 2. So this is suppose minus 1 upon root 2. This point we are getting. So when we draw it, it will be like this. Okay, so at t is equal to 0, we are getting this point, and at t is equal to t by 4, we are getting this point. And similarly, you can substitute the t is equal to t by 2, 3t by 4, etc. Then you will get the complete elliptical polarization in this way. That will be the complete electrical polarization in this form. Okay. Now, as you can see that it is moving in this direction and the direction of propagation is z. This is the z which is outside the board. Now if I match it, then you can see that the thumb should be in the direction of propagation which is outside the board and my circulation will be in this direction. So that is satisfied by left hand. So that is why it is left hand elliptical polarization. So this is your option A correct. But because it was an MSQ question, more than one option can be correct. And what can be the other options in the similar way? If you will take let's take the option number B. So if I write according to option number B, this will you can check it, okay, because I am writing directly because I don't want to change the slide again and again. So this is 2ax plus cos omega t and ay cos of omega t plus pi by 2, omega t plus pi by 2, right? So if I put t equal to 0, at t is equal to 0, it will be 2ax and 0 into ay. And if I put t is equal to t by 4, then this e will be cos pi by 2 0. So 0 into ax and minus ay, okay, minus ay. So when I draw it here, this is x, this is y. So in the first case, at t is equal to 0, the amplitude is 2 and y is 0. That means in the x-axis y will be 0 and it is minus 1 and x is 0. So in the y-axis x will be 0. So these will be the rotation and this will be the direction of propagation. So again, this is at t is equal to 0, you will get this point, and at t is equal to t by 4, you are getting this point. So this is also left hand elliptical polarization, you can directly see. This is again, the rotation is same and the direction of propagation is also same. Now let's take another example, another option, which is c1x is 1 and this c1y is 2 and the theta is 3 pi by 2. So this is 1 and it is 2 and it is 3 pi by 2. So this 3 pi by 2 I can write it as ax cos omega t plus 2 cos omega t minus 90 also I can write. Okay, so according to that, at t is equal to 0, the electric field will be, this is E will be 0 at t equal to 0, the cos 0 will be 1 and we will get ax cap plus ay into 0. This is ay also. So ay into 0, and at t is equal to t upon 4, the electric field will be pi by 2, this will be 0 and this will be 1. Okay, so in this way we will get. So now if I draw it, so this is y, this is the direction of propagation, this is x. Now the x at t is equal to 0, y is 0 and x is 1, and here the y is 2 and x is 0. So we are getting this direction, okay, because we are getting at this one. First of all, we are getting at t is equal to this 0, this point, and then we are getting t is equal to capital T by 4. So you will get this. Now it is satisfied by the right hand. You can see that the thumb should be in the direction of propagation and this will be the direction of rotation. So this is right hand elliptical polarization. Okay, so we have already got this option A left hand, option B left hand, option C right hand. So we need a left hand elliptical polarization. So we have to check one more option. So according to this, the options are, this is option D I am talking about. So E is equal to, we are getting the amplitude is 2 and this is 1. So 2 cos omega t ax, and it is cos omega t plus 135 ay. The angle is given is 135. So when you put t is equal to 0, cos 0 is 1, so this is 2ax, and this is 135, so minus 1 upon root 2 ay. And when the t is equal to t by 4, this is cos pi by 2, which is 0, and this is t by 4, pi by 2, 90 plus 135, 225. What is the value of 225? Minus 1. Minus, we are getting t by 4, na? So cos pi by 2 at t by 4, yes, minus 1 by root 2, minus 1 upon root 2 only, the same value, minus 1 upon root 2. Okay, so now if I draw it, at t is equal to 0, we have the x amplitude as 2 and the y amplitude as negative. So this is the point for t equal to 0 we are getting. This is x2 and this is minus 1 upon root 2 in the y-axis. This is the direction of propagation, z, positive z. And at t is equal to t by 4, x is negative and we are getting the y same. That means we are getting this shape. Okay, we are getting this shape. So when you will draw again, you will get this type of elliptical polarization in this form. So what is the rotation and what is the direction of propagation? The direction of propagation outside and the rotation is in this way only. So in this way, that is again satisfied by the left hand. So that is satisfied by the left hand, and we have already seen that why all the options are elliptical. So the correct answer will be now A, except B, all the three options are right now, except C or B. Except, okay, C was right hand. C was right hand. A, B, D. A, B and D. This is the right answer. Now, let's move into the next question. Question number 39. So, this is the question from the transmission line, and the following circuit representing a lumped element equivalent of an infinitesimal section of a transmission line is an R. So which is the correct representation of the transmission line in the lump element equivalent? So again, to say this, we have to take one extra slide. Okay. Okay, so now to understand the transmission line equation, you should know that what is the equivalent equation of voltage and current, because the voltage and current should be satisfied. Voltage and current equation should be satisfied for any circuit to be a equivalent circuit of a transmission line. So what is the equation? That equation is del V upon del Z is equal to minus of R plus j omega L into I. Okay, and the another equation is del I upon del Z is equal to minus of G plus j omega C into V. So this equation, if satisfied by any equivalent circuit, then we can call it as a transmission line or equivalent transmission line or valid equivalent transmission line. Okay, so that we have to apply in all the options one by one. Again, it is a quite lengthy question, but just by looking or deriving the one option, we can conclude about the other option. So we will do it for the one option. So that is, let's take the option number A. So option A, L and R is there, and here C and G is there. So the voltage in this point, which is the input point, is V Z comma T, and it is the output point. So this is the voltage which is V z plus delta z comma t, because this is a very small length of unit element and the length of the unit element we take is delta z. Now the current, when we apply the KVL, we don't take the voltages in the parallel branch. That is the assumption. The current is not flowing in this branch. Suppose when we apply the KVL, we apply only in the outer loop. So the drop across this and this we don't take. Obviously, well, we are applying in the outside or outer loop, then we don't need to take. So what is the current here? If I take the current over here is I z comma t. Okay, in this part we are not taking the current in this branch and the current in this branch. We are taking the current in this branch as 0. Or you can say if the current is not present, that means it is open circuited. Okay, it is open circuited. So for the outer loop only we will apply the KVL. This is the assumption you can take for any transmission line to derive the equation of a voltage and current. So when you apply in the outer loop only, what we will get? You will get the Vz comma t, that is minus to plus, then minus of I into R into delta z. I was Iz delta comma t. So I z comma t actually, and delta z, that is the resistance. So resistance and current. Now minus j omega L into delta z into I z comma t, then minus of V z plus delta z comma t equal to 0. That is by applying the KVL in the outer loop. So if I write it, if I take the voltage in the right hand side, this is the voltage which I am taking right hand side, this is the voltage which I am taking right hand side, so it will become negative, and it is same at this place. So delta z is common, I z comma t is common, and we will get minus also common, R plus j omega L. So if I divide it by delta z, okay, if I divide it by delta z, and if I take the limit delta z tends to 0, and here also if I take the limit delta z tends to 0, we are getting R plus j omega L and I z comma t with minus sign. So this will become the differentiation V z comma t divided by dz is equal to, delta z is not present over here, so there will be no effect, and it will become R plus j omega L into I z comma t. So this is the first equation which we are getting, and it will be taken as the current equation, voltage equation. So it is proved that the voltage equation is satisfied. So but not only one equation, both the equations should be satisfied for a transmission line to be a valid transmission line, or the circuit to be a valid equivalent circuit of a transmission line. So we have proved about the voltages. Now let's take about the current. See, in this outer loop I have applied. Now if I take the current, if I want to write the current equation, then what I have to do? The current equation, we will not take the current, we will take in this part and this part, so and this part. So we will assume that in these two sections the current flow will be same. So that means there will be a negligible current in this branch now. Negligible. Okay, this is negligible current we are taking. So you can say that the same current is flowing in these two branches. So here the current was I z plus delta z comma t, okay, in this outside, and in these two branches the current is same. Not same actually, we will say here the current we are saying at approximately 0. So the current which is entering, here, and in these two branches current is same, and then the current is at this point. Okay, so you can say this is, if I take current 0, then you will say, sir, it should be open circuited, then this circuit and this part will be eliminated. So we will not take the current as 0, because otherwise it will look like that. But what we are assuming, the voltage in these two part is same. That's better. Okay, voltage in this section and voltage in this section are same. So the voltage drop I can take 0. In the previous case, the current in the branches was 0. Now I am saying the voltage drop in this part is 0. So we will take only the voltage same in these 2 points, so that in this point and this point and in this point, in both the point the voltages are same. So in this point the voltage is Vz comma t. So here also it will be Vz comma t, not Vz comma delta z. So we will take the voltage same. This is the assumption to actually reduce the calculation. Otherwise it can also be done like that. You can take the voltage here, but what will happen in that case, you have to write 3 equations, and 3 equations then you have to substitute, it will become lengthy. And that solution we have given in our PDF that you might have downloaded from our app. So in the PDF we have derived in that form, but obviously when you solve in the question in the examination, then you cannot take that much lengthy step. You have to reduce by some assumption. You have to reduce the calculation. So we are reducing the calculation by assuming that voltage at the point A and voltage at the point B are same. So if voltage is Vz comma t, then what will be the current? This is in the shunt, it is connected, so it is admittance. So you can calculate the current V into j omega c delta z by 2. Okay. So now let's calculate. So as I said, V z comma t j omega c into delta z upon 2, and the current, it is leaving, so that is positive. The current which was entering is I z comma t in the diagram. Okay, you can see again if you want to. Here you can see the current it is entering is this one, na? I z comma t. I am applying the KCL. So this is the leaving I am taking positive. There is no current here because we are assuming that there is no drop here. So the current is this, that is again leaving, so that is also positive, and this is again leaving, so that is also positive. So the current is leaving. Which current? I z plus delta z comma t was leaving, and the next current, that is also leaving. I am taking positive. So this is J, not J, that was admittance, na? So it is G by 2 delta Z I Z comma T equal to 0. Okay, it was like this. Now if I take these two in the right hand side, not I have written I, this is current we are writing, so it should be voltage. Voltage we are taking same, so V divided by, or V into admittance is your current. Now I am taking these two in the right hand side, so this current I am writing in this part in the left hand side only, minus I z comma t. Okay, and these two I am writing in the right hand side. So V z comma t is common in both, minus, because both will be in the right hand side, so it will be minus, and it will be G plus j omega c. Okay, G plus j omega c divided by 2 also, so delta z divided by 2, like this. Okay, this delta z I am taking common, so limit delta z tends to 0, I z plus delta z comma t minus I z comma t divided by delta Z, right? Now it is equal to minus of V Z comma T and G plus J omega C divided by 2. So this is d I Z comma T divided by dz is equal to the limit we have to take here also, limit delta Z tends to 0. So there is no delta Z, so no effect. So minus V Z comma T G plus J omega C divided by 2. So this is not satisfying our current equation. How? This is the current equation. So in the current equation we should not have any divide by 2, but here when we are calculating it is coming as divided by 2. And why it is coming as divided by 2, if you notice this part, then you can directly tell the other options will be valid or not. Why it is divided by 2? Because this part and this part, if you will add them, okay, because we are assuming that there is no voltage drop in this, so we are taking this as a single branch. So when you are adding these two parallel branches, you are getting G plus C divided by 2, G plus J omega C divided by 2, because there is no addition, and addition is not making it as a 1. Now similar way, if you will do here, you can see that these two branches will give you R plus J omega L into delta Z, okay, and these two branches, they are connected in parallel, so when you will add them you will get G plus J omega C. So here there is no divided by 2 term is coming, so definitely it will be a valid one. Okay, now again if you will check the other options like this, so this is the branch, when you will apply the KVL in the outer loop you will get R plus J omega L, right? And in the similar way, when you add this branch and this branch, that parallel branches, if you will add, when you will add all the parallel branches, then you can see this G by 2 delta Z, G by 2 delta Z, G by 2 plus G by 2 will become G plus J omega C delta Z, J omega C delta Z divide by 2 is there, so again it will become plus C. So G plus J omega C, so that is also correct. So it will come in this form. There will be no divide by 2 term will come. Here also if you will add in the outer loop, you will add in the outer loop R by 2 will become R, L by 2 will become L. Here it is simple, G and C directly given, so G plus J omega C. So all these three options B, C and D are correct. Okay, all the three options B, C, D are correct. And how to calculate, that is the procedure I have given you. Now let's take the next question of EMT, that is the question number 40, and I think this is the last one. Yeah, so this is the last one. A transparent dielectric coating is applied to the glass. Epsilon R is equal to 4, mu R equal to 1 to eliminate the reflection of the red light. Lambda naught is equal to 0.75 micrometer. The minimum thickness of the dielectric coating in the micrometer that can be used. So here it is saying that we have a glass, the coating is applied in this way. This is the coating of the dielectric, and then it is the air, and here it is the air. So we have air, this is the dielectric, and this is the glass. So we have the three different mediums. So the impedance, intrinsic impedance will be eta 1, eta 2 and eta 3. So it is very much similar to the characteristics in the transmission line. What is the purpose of the lambda by 4 length transmission line? To match the impedances. So here also this dielectric should be having the length in such way that there should not be to eliminate the reflection, there should not be any reflection. So we have to eliminate the reflection, and the reflection can be eliminated when the impedance are perfectly matched. And by the analogy to the transmission line, what should be the impedance of the lambda by 4 transmission line? The lambda by 4 transmission line should have the impedance, suppose this is the thickness D. So this lambda by 4 length transmission line should have the impedance is equal to the geometric mean of the impedance to be matched. So the impedance we want to match is eta 1 and eta 3, because we don't want any reflection from the of the red light from the glass. So we want to match it perfectly. Here it is to eliminate the reflection from the red light. So you have to match it. So when you will match it, you have to take the impedance is equal to geometric mean of eta 1 and eta 3. That is simple concept of transmission line, that if you have the lambda by 4 length transmission line or odd multiple of lambda by 4 transmission line, then the impedance should be geometric mean of the impedance to be matched, and we want to match these two impedances. Okay, we also know that eta is inversely proportional to 1 upon epsilon r. Correct? Eta is inversely proportional to 1 upon epsilon r if the mu r is 1. If the mu r is 1. Okay, so this, from this relation we can write this epsilon r2 is also equal to epsilon r1 into epsilon r3. What is the epsilon r1? The epsilon r1 is that glass is having the refractive index 4. And what is epsilon r3? Epsilon r3 is air. So air will have the I said refractive index, I think. No? So epsilon r is the relative permittivity. Relative permittivity of the glass is 4. The relative permittivity of the air is 1. So it is 2. Okay, so the epsilon r2 is 2. Now we want the wavelength, because what I said is the distance should be odd multiple, because what is the characteristics of the quarter wave transmission line? The characteristics of the quarter wave transmission line is the odd multiple of lambda by 4 should be having the characteristic impedance that is equal to the geometric mean of the impedance to be matched. So from here, because by the analogy of the transmission line, I am writing here, by analogy of the transmission line, this thickness should be odd multiple of lambda by 4. So what is that lambda? So this lambda you can calculate as lambda naught by 4, lambda naught by root over epsilon r2, because we are talking about that thickness. The wavelength should be at that particular thickness. So what is the lambda naught? This is 0.75 divided by root 2. So this is equal to 0.53 micrometer. Now because it is asking for the minimum thickness, so minimum thickness you will get for n equal to 0. So n equal to 0 you will get lambda by 4 only. So this is 0.53 divided by 4. So the D is equal to 0.1325 micrometer. So answer can be approximated to 0.133 micrometer. So answer is given as 0.13 micrometer in the GATE examination. So the answer is 0.13. Okay, the range was given as 0.12 to 0.14. So this is all about the questions of electromagnetic theory. So now we have the next question, which is from the communication system. So for a real signal, which of the following is or are valid power spectral density? So for a valid power spectral density, what are the different properties? So the different properties are nothing but a power spectral density should always be greater than 0. Okay, it can be greater than equal to 0, and it should follow the even symmetry. That is this one. So you can check which one is following this. So 2 upon 9 plus omega square, if you replace omega by minus omega, then it will follow. And here also if you will substitute omega by minus omega, then also it is follow it, because it is e to the power minus omega square. So when you replace omega by minus omega, you will get same, and this is cos square again in the omega. This sx of omega is negative as I said, it should always be greater than equal to 0, so it is negative, so it cannot be the correct, and it is only one-sided, so it is not showing the even symmetry, so it is also not correct. So the correct answer for this question will be A and B, right? Now coming to the next part. The signal to noise ratio of an ADC with a full scale sinusoidal input is given to be 61.96, the resolution of the ADC in bits. So we want to calculate in bits. So let's take, I'm keeping the calculator with me. So because it is given as the sinusoidal input, so for the sinusoidal input, what is the signal to quantization noise ratio? So signal to quantization noise ratio in dB is given as 1.76 plus 6n. So it is 61.96 equal to 1.76 plus 6n. Okay, so this is 61.96 minus 1.76, it is 60.2. It is 60.2 is equal to 6n. So n is rounded off to 10. So n is rounded off to 10. So nearest integer is 10. So answer is 10. Okay. The next is now we have the question from the random process or random variable, that is the transformation of random variable. A random variable x is distributed normally and 0, 1 undergoes the transformation y is equal to hx given in the figure, the form of the probability density function. So the PDF will have the form in which way. Okay, so here you can see that what are the different values of y. So the y is having value 1 and it is some variable here, and y is having some 0 and again it is variable and it is -1. So if I say the value of y it is possible is -1 and some function of x. So let's take h1x and this one h1x, because it will be function of x, it is variable now in this range. When you change the x, you will get the different y, and then it is 0. Okay, and then again it is the variable x as a function of x, and it is 1. Okay, so we are getting these three different values. So because it is a discrete part, distinct value in the -1, 0 and 1. So when we write the PDF, when we have the distinct values, we write the PDF in the form of impulse. So this is the probability of x we want to calculate. So the probability of -1, the probability of -1, what can be the probability of -1? It is not given, right? It is not given, so we will take it as in general. So let's take the probability of -1. The probability of -1 is suppose A, it is h1x, the probability of h1x, and then probability of 0 is B, and this is the probability of h2x. We have to write in general, and then comma probability of 1, that is C. Probability of 1 we are taking as C. So how do we write? The PDF is probability is A delta y plus 1. Okay, because the value is at 1, at -1. So how do we write the PDF? The PDF we write in the form of P of Fy of y is equal to summation I equal to 1 to m probability of yi, and then delta y minus yi. So the value I am writing is -1, so y plus 1 it will be, and what is the probability of y equal to -1? We have taken a, so that is why a I am multiplying. Now if I put I equal to 2, then I will get the some probability which is h1x. So that we are not writing, because in the options they are simply written in the form of G, so that I am not writing right now. For 0, what is the probability? This is B, and that is y minus 0. For the 1, what is the probability? It is C, so that is y minus 1. and the remaining is function of y. When you will put these probabilities and this what will be that function, because it is continuous, so that function should be given. When they will give the function, then only we will be able to calculate its PDF. So we are writing in general, that is g of y. So which one can be the correct answer? The correct answer where the y equal to 0, the y equal to 1 and y equal to -1 and g. Yes, so correct answer is option B. Option B. See, here it is the value of x, it is written. The point where the value of x is -2 and x equal to 2, that they are written in the option C. So be careful. We have to write inside the argument as the value of y, not the value of x. Okay, so option B will be the right answer for this particular question. Now coming to this next question, it is a very good question actually. Let a frequency modulated signal is x of t a cos omega t plus kf minus infinity to m lambda d lambda, and where mt is message signal having the bandwidth w, and pass through a nonlinear device which is 2xt plus 5x square t. That means we are squaring it and we are also adding it like a nonlinear device. In the square law modulator we did the same thing. The bt is the bandwidth. The bt is the bandwidth of the FM signal. Then what is the minimum value of WC required to recover our FM signal? Okay, so let's take we need a blank slide here. Okay, so first of all you should know that when we pass it through the nonlinear device, what will happen? So when you pass any FM signal through a nonlinear device, okay, the device which is taking the power of n or the multiplication factor n. So suppose this is an FM signal x of t and this is also an signal yt. This is also angle modulated signal, any angle modulated signal or FM signal. This is also angle modulated signal. Then in this case, if you give the, because it is angle modulated signal, so this angle modulated signal will have the form AC cos of omega c t plus kf integration minus infinity to t m lambda d lambda. This is a standard form of angle modulated signal. So it will have the carrier frequency omega c, it will have the frequency deviation delta f, it will have the message signal frequency FM or W, and it is having the modulation index beta. Okay, now when you pass it through the device which will multiply it by n and or which is having the power of n, then you will get yt. That yt will also be angle modulated signal. This will also be angle modulated signal, but its carrier frequency will change by factor n. It will change by factor n, that is n omega c. The frequency deviation will also change by factor n. The modulation index will also change by the factor n. Okay, that will also change by the factor n, and the message signal frequency remain unchanged. So these things you should know before solving this question. Now let's solve this question, because this is the bandwidth, this is FM signal, and the bandwidth is also given. So how do we calculate the bandwidth of FM signal? The bandwidth of FM signal is calculated by its Bessel function equation. So what is that Bessel function equation? So we are writing x of t. So x of t, if we want to calculate its bandwidth, we calculate the bandwidth from the Carson rule, that is the approximation. Okay, so that is actually from n equal to minus infinite to infinite, and your j n beta into AC, then cos of n omega c plus FM. So the message signal is having the bandwidth W. So let's write W in this question. The bandwidth of the message signal is given as W. So we are writing like this. And by the Carson rule, the bandwidth is given as 2 times delta F plus W, that is FM. This is the bandwidth which is given to us. Now, if I draw this, okay, if I draw, then we will get this as the carrier signal. This is the sidebands. I am writing magnitude only, so that's why I am drawing only positive section. So don't think that it is negative also for the odd values. I am drawing the magnitude x of f mod. So all the negative values also I have taken positive. Okay, so this is the carrier frequency omega c, and here it should be omega c plus bt upon 2, and here it should be omega c minus bt upon 2, then only the bandwidth will be bt. Okay, then only the bandwidth will be bt, right? Is it clear up to this part? So if you will take the difference from, because how do we calculate the bandwidth? The bandwidth is nothing but the difference between the highest frequency minus lowest frequency. So highest minus lowest. So what is highest? Highest is omega c plus bt by 2. What is lowest? Omega c minus bt by 2. Then when you take the difference, you will get bt. So this is the x of f, that is the spectrum of this particular plot. Now we have to take the two different plot. One is the x of t, because it is given that y of t is equal to something like 2 of xt and plus some 5x square t something. Let me check once again. 5 is there, or means magnitude doesn't matter, but still 2 and 5. Yes, 2 and 5 is given, x of t and x square t. We have to draw the spectrum of that particular signal, means y of t. Now we have to draw the spectrum of y of t. So how will you draw the spectrum of y of t? Y of t is the addition of two signals. So first of all, you have to take xt. So what is xt? This is omega c, and these are the side bands, and here we got the omega c plus bt upon 2, and this will be omega c minus bt upon 2. Now what about the square term? What about the square term? Square term will have the carrier frequency. This is because of xt. Okay, and now I am drawing because of x square t. So what will be the difference between the square t and xt? When you square, the carrier frequency gets double. So that means that will center around 2 omega c, and again the sideband will come. Now what can be the minimum value? Okay, what can be the minimum value? So because x square you are doing, so that means because you are doing the x square, so when you will perform the x square, frequency deviation get also double. So let me write the new bandwidth. The new bandwidth will be 2 times the frequency deviation gets double, but that will not change. Which will not change? The message signal frequency will not change. So you have to take the 2 omega c plus delta f plus w, or actually I should write bt. It should be from the previous case, the bt minus plus delta f. Okay, and 2 omega c plus BT by 2, right? And then plus delta F. Oh, let me write here, plus delta F. Okay, and the lowest bandwidth should be 2 omega C minus BT by 2 minus delta F. This is the frequency of this point, and this is the frequency of this point. Is it clear? Okay. Plus delta F. This is plus delta F, no? This is not minus sign. Clear? See, here we have omega C plus BT by 2. Now what is the change in the previous bandwidth? The frequency deviation is doubled. So frequency deviation, this 2 delta F you have to include. So how will you include 2 delta F? When you will add the delta F in the positive side, and when you will have the delta F in the negative side. So when you will take the difference, you will have the 2 delta F. Okay, when you will take the difference, this difference when you will take, then the new bandwidth BT dash is BT plus 2 into delta F. That is the difference now. When you will write it, it is nothing but the 4 delta F plus 2W. So that is nothing but the 2 delta F plus 2W plus 2 delta F. So this is nothing but your BT, and this is nothing but your delta F. So this is BT plus 2 delta F. So that is the difference. So the previous bandwidth was BT. The previous bandwidth was BT. And now because of square term, you are getting BT plus 2 delta F. Right? So this is the relation. Now we want to recover this. We want to recover this, and we want to eliminate this part. This is x square t part. So how can we eliminate them? We can separate them when these two components will not overlap. We can separate them when these two elements are not overlap. So this should not overlap with this. This is the lowest band, and this is the highest band of xt. The highest band of xt should not overlap with the lowest band of x square t. Then only these two will be separated, and if these two will be separated, then only we will be able to recover x of t with the help of band pass filter. Okay, because when you put the band pass filter over here, then it should not pass any sideband of the x square t term. So we should not have the overlapping between these. So what is the condition? The omega c plus bt by 2 should always be less than 2 omega c minus bt by 2 minus delta f. So from here we will have omega c should be greater than, this will be bt plus delta f. Okay, are we getting this? Bt plus delta f. Now what is the value of bt? Bt was 2 into delta f plus w plus delta f. Okay. Now let me write over here, omega c must be greater than 3 by 2 into 2 times delta f plus w. Okay, I am adjusting that. Suppose if I will adjust like this, this is minus 2 and 2 will get cancelled, 3 delta f. Yes, so here we have actually 3 delta f. If I write this is nothing but a 3 delta f plus 2w. So that I am adjusting. So when you open it, you will get this 2 and 2 get cancelled, so you will get 3 delta f, and from here you will get 3w. So this is the w, so that w you have to subtract. So this w you have to subtract. Yes. Okay, so this is omega c greater than 3 by 2 in bracket 2 into delta f plus w minus w, because when you open it, this 2 and 2 will get cancelled and it will become 3 delta f as the previous one, and when you will open it again, this 2 and 2 cancel and 3w minus w, 3w minus w is 2w, so that is correct. So in this way I am adjusting it because the option is given in the form of bt. So this is 3 by 2 bt minus w. So we have got this result 3 by 2 bt minus w. So this w is small, so we can neglect that. So w is small, so you can neglect that. So what is the minimum value of omega c? The minimum value of omega c is 3 by 2 bt. So the minimum value of omega is 3 by 2 bt. So correct answer for this question is option B, the minimum value. So that is 3 by 2 bt. Okay. So in this way you have to solve. This is the only question which was good in this year in the GATE 2023 from the communication. Otherwise the rest questions are very easy. So this is the another question. X1t and X2t is band limited to the signals having the bandwidth B is equal to 4 pi into 10 to the power 3 radian per second. So the frequency, if I write the frequency, then the frequency will become 2 kilohertz. Okay, and we have to calculate the Nyquist rate for this. So both the signals are having the frequency 2, right? So both the signals are having the frequency 2. So this is X1t. X1t is having 2 kilohertz, and this is also having 2 kilohertz. So let's take it as Y1t, and this is Y2t. So Y1t will be band limited to, because Y1t is nothing but the X1t multiplied with cos. This is also 2 pi into 2 into 10 raised to power 3t, and Y2t is X2t cos 12 pi into 10 raised to power 3. So if I write in the form of 2, so this is 2 pi into 6 into 10 raised to power 3t. So when we multiply the two signal, what is the maximum frequency we get? Because these two are again added, na? So these two are again added. So what is this? Yt is equal to y1t plus y2t, right? y1t plus y2t. Now what you have to do? Because it is the multi-tone signal. Now yt, we want to calculate the sampling frequency for yt. And for the multi-tone signal, the sampling frequency is twice of maximum frequency. So we have to find the maximum frequency of y1 and y2. So what is the maximum frequency of y1? When you multiply the two signals, the maximum frequency is addition of the frequencies. So addition of frequency means the frequency of x1. x1 is having the frequency 2 and cos is having the frequency 2. So the frequency we are getting is 4 kilohertz for the x1. Because when you multiply the two signals, you get the maximum frequency as addition of the two signals, because you can take this x1 as cos, this is also cos. So cos A, cos B, that is cos A plus B and cos A minus B. So A minus B will definitely not give the maximum value. When you add them, then you get a maximum value. Okay. So here also it is 2 plus 6. So what you are getting? 8 kilohertz. So this is the 8 kilohertz, this is the 6 kilohertz. So this signal is band limited to 4 kilohertz and this signal is band limited to 8 kilohertz. So what is the maximum frequency? The maximum frequency is 8 kilohertz. So the sampling frequency is twice of maximum frequency. So this is twice into 8, which is 16 kilohertz. So the omega s will be 2 pi into fs. So this is 32 pi into 10 raised to power 3. Okay, because it is asking in the radian per second. So you have to calculate in the radian per second. So our answer is option D. Okay. Next. So this is the white Gaussian noise with the power spectral density 1 by 2. X of t is input to LTI system with the impulse response e to the power minus t ut, the average power of the system. So this is the question. This is LTI system. This is your signal yt. This is your signal xt, suppose. Then we know that Sy of f, the relation between the power spectral density is h of f mod square into Sxf. And if I want to calculate the average power of output, then I have to integrate or calculate the area of output. Okay, area of the output we want to calculate. So this is power spectral density of output. How will you calculate this? H of f mod square into Sxf df. Substitute that values. So what is the H of f? H of f you will get, this is 1 upon 1 plus j omega. Okay, this is H of omega. So H of omega square you want to calculate, right? So H of omega 1 upon 1 plus omega square, you can say. Correct? So, and this is only for the 0 to infinity because of the limit ut. This is 0 to infinity. This is 1 upon, this is mod. If you will calculate, then it is root over, and because we are calculating 1 plus mod square, so this is 1 plus omega square into 1 upon 2 d omega. If I want to calculate in omega, then it is 1 upon 2 pi. So 1 upon 4 pi tan inverse of omega, limit from 0 to infinity, then it is pi by 2, right, into 1 upon 4 pi. So this pi and pi will get cancelled. And one more thing, that is up to 2 decimal we want to calculate. So this pi and pi will get cancelled. 1 upon 4 pi, this because of this 2. So because this is only defined for 0 to infinity, it is 2 times 0 to infinity now. Because this is the only defined for 1 second. Hmm. One upon 1 plus j omega, that is correct, and that is also correct. This is pi by 2, 0 is 0. We should have, here it is somewhere, it is, I'm doing mistake. This is h of f. H of f is only defined for 0 to infinity. So yes, actually, wait, this is minus infinite to infinite only. This is minus infinity to infinity. The limit will be same because this h of omega is not only for the right hand side, right? This is the h e to the power minus t ut. So in the time domain, it is only for the right hand side. But when you calculate for the in the frequency domain, then it is 1 upon 1 plus j omega. So that is minus infinity to infinity only. And when you put the upper limit and the lower limit both, then it is pi by 2 minus of pi by 2. So you will get pi. You will get pi. And then this pi and pi will get cancelled and you will get 0.25. That is 0.25. So answer is 0.25. Okay. So don't write the limit because the limit is from minus infinite to infinite, so it will remain same. You don't need to take the limit of ut. This is not we are writing inside the Fourier transform, inside the integration we are writing the h of f, not h of t. If I write h of t, then I have to take the limit from 0 to infinity. But because I am writing the h of f, then you can take it directly minus infinity to infinity. Okay. Now let's take next question. So the frequency of occurrence, this is from information theory. This is also a good question because understanding of the question is important here. The frequency of the occurrence of the 8 symbol is shown in the table below. A symbol is chosen and it is determined by asking a series of yes or no questions which are assumed to be truthfully answered. The average number of questions when asked in the most efficient sequence to determine the chosen symbol. So when you will ask the question yes or no whether it is A, yes or no, will get the information about A. Similarly for B symbol, you will ask whether it is B or not. So you will say either yes or no. If it is yes, then it is B, otherwise it is not B. So you will keep asking up to the G, because once you will understand that you have got the answer up to G, then automatically the next symbol will be H, because once you get the information up to the G, once you get the information up to the G, then automatically you will understand, because the 8 symbols are there, A to H. So if you know the information up to G, then automatically the last symbol will be H. So that is why the information we don't need to calculate for H, only up to G you have to calculate. So what is the entropy? That is the average information, that is summation over I equal to 1 to 7 probability of any symbol X and log base to 1 upon probability. So this is nothing but a probability is 1 by 2 and log base to 1 upon probability. The probability, frequency of occurrence means probability, so that is 1 upon 1 by 2. So this is 1 by 4 log base to 1 upon 1 by 4, so that is 4. Okay, so that is 1 by 8 log base to 8, then 1 by 16 log base to 16, then 1 upon 32 log base to 32, then 1 upon 64 log base to 64, and 1 upon 128 log base to 128. Okay, up to this value only. You don't need to take the value at H, otherwise it will be wrong, because once you know the information up to G and you know the symbols that is transferred is only A to H, then if you know the information up to G, then automatically the last symbol will be H. So there will be no uncertainty remaining. If you know the information of G up to G, if you know the information up to G, then there will be no uncertainty left for the symbol H. Okay, so when you will calculate it, you will get 1.98. So up to 2 decimal it is asking, so the answer is 1.98. Okay, so this is all about the questions of the communication and EMFT. I hope that you have understood now all the solutions in detail, and if you still have any doubt, then you can just give us a comment over the comment section. I will try to clarify that in the comment. So now the Rakesh sir will come and he will discuss the remaining question of GATE 2023, which is mostly the mathematics and aptitude. Thank you.
Okay, thank you so much Saket sir for the wonderful discussions of the questions of communications and electromagnetics. And now guys, once again I, Rakesh Talreja, will continue now towards the end for the question of engineering mathematics, to be followed by general aptitude as well. So let's first go through the 1 mark question. This is a MCQ 1 mark question here. Let V1 and V2 be two vectors as given to you. The value of the coefficient alpha in the expression V1 is equal to alpha E2 plus EE, which minimizes the length of the error vector. So here they call the E as the error vector and they are talking about minimizing the length of the error vector. So first of all, what is this error vector? Okay, that is going to be V1 minus alpha V2, isn't it? V1 minus alpha V2. Now both the vectors have been mentioned. So V1 is 1, 2, 0 minus alpha times the V2 vector, which is 2, 1 and 3. Okay, and forming the E vector will be turning out to be 1, corresponding element subtracted 1 minus 2 alpha. Then second is 2 minus alpha and third is 0 minus 3 alpha, that is simply minus 3 alpha. This is the error vector. Now what about the length of the error vector? We need to minimize the length of the error vector, and what is going to be the length? Now if length is minimum, length square will be minimum. So if you want to take the length, you know it is root over x square plus y square plus z square for a vector. So why to take under root? Okay, let's take it as length square. Let us take it as L square. Okay, so here let's say L is the length. L is the length, and let us talk about L square, and L square will become x square plus y square plus z square. So here x term is 1 minus 2 alpha. So 1 minus 2 alpha whole square plus next is 2 minus alpha whole square plus minus 3 alpha ka whole square. Minus 3 alpha ka whole square. Okay. So this L square will become how much if I expand? Yeah, see, if you want, you can open a plus b whole square and simplify. Yeah, if you want, you can differentiate here only, because it is all about minimizing the length of the vector. Okay, so let us say there is some function f which is function of alpha which is equal to L square, right? Which is equal to L square. So what is going to be the derivative of this function? Okay, derivative of this function. So let's differentiate this directly. 2 into 1 minus 2 alpha, chain rule says minus 2 multiply karenge, plus again twice 2 minus alpha, with the chain rule I multiply minus 1, and this is how much? This is 9 alpha square actually. So 9 alpha square ka derivative 2 alpha, and to find the minima we should take the first derivative equal to 0. So this is minus 4 into minus 2 to plus 8 alpha, right? This is minus 2 minus 4. Right, and minus 2 alpha into minus 1 plus 2 alpha plus 18 alpha equal to the 0. So we have total, this is 10 and 18, 28 alpha, I think. 28 alpha, and this is minus 4, let's send it on the right side equal to 8. The alpha will be 8 by 28, or if you cancel by 4, it is going to be 2 by 7. Alpha is equal to the 2 by 7. If alpha is 2 by 7, what is going to be f double dash alpha? Okay, let's confirm minima. Although value is obtained, alpha will be 2 by 7 is the answer. But same time, okay, at the same time, if you take, this is what is the expression for f dash alpha, right? This is what is the expression for f dash alpha. But if I show you here, what is going to be the double derivative here? The double derivative looks like 8 plus 2 plus 18. Okay, that is 28 alpha. So f double dash alpha will be 28, right? I can simply say that f double dash alpha will be the 28, which is positive, confirming minima. Whenever the second derivative is positive, it confirms the presence of local minima. Yes. So at alpha equal to 2 by 7, that is option number C, alpha equal to 2 by 7, you will get the minimum length of the vector, right? We need to minimize this length. This will be minimum, right? L square is also minimum. If L is minimum, L square is minimum. That is the ideology we have used. Moving ahead quickly to the next question. Again, a MCQ 1 marker question here. The rate of the increase of a scalar function, rate of increase and rate of decrease, in general, rate of change of a scalar function in a specific direction. In a given direction 2, 1, 2. So rate of change of a scalar function in a specific direction, that is what is known as the directional derivative of that function. So this question is on the directional derivative, one very expected type of question. Okay, so directional derivative of any scalar function phi, in short let me call it as dd, okay, of any function phi at the point P, right, in the direction of some vector, right, in the direction of some vector which is mentioned here V, is given by what formula? It is given by gradient of the function at the point P, right, at the point P, dot product with V hat, dot product with unit vector along that direction. Okay, so let us just substitute the values here. So what is going to be the directional derivative? Okay, first the function is x, y, z. So what is going to be the gradient of f? As we all know, the formula for gradient of f is del f by del x into I cap, del f by del y into j cap, del f by del z into k cap. So when you differentiate this partially with x, okay, x ka derivative 1, you are left with yz, which is constant in partial derivative. Similarly, differentiation with y will give you xz, differentiation with z will give you xy. Okay, that is what it is. But I need the value of the derivative at the point P, the point P is 0, 2, 1, right? So x is 0, okay, y is 2, z is 1, right? X 0, so the rest two components are 0, so it is simply equal to 2I cap, okay? It is simply equal to 2I cap, right? Now what is the directional derivative? As I already written, it is the gradient at the point P dot product with V hat, that is the gradient at the point P dot product with V hat, which is given by V upon mod V. How do you get the unit vector? A vector divided by its length divided by its magnitude here, right? So the gradient is 2I. The vector is directly given to me. It is in the vector form gradient 2, 1, 2. It is in the column vector form. If I convert ijk form, it is 2I plus j plus 2k divided by its magnitude. So what is its magnitude? Under root of 2 square plus 1 square plus 2 square, root over x square plus y square plus z square. So ये कितना हो गया? 2I dot 2I will be 4. Okay, so only I component multiply, there is no j and k here, divided by under root of 9, which will be equal to 3. ठीक है, so 4 by 3 should be my answer. That is option number B. 4 by 3 is the answer. Moving ahead to the next question here. Okay, number 50. Yeah, let W power 4, again MCQ 1 mark, a good question from basic of complex numbers. Let W power 4 is equal to 16J. Which of the following cannot be a value? Cannot be a value of W. Cannot be a value of W. W power 4 is 16J, right? Okay, 16J. So what is going to be? What is going to be W square? What is going to be? First take 1 under root. Okay, so taking the under root you get W square, but what is the under root of 16? We write it as plus minus 4 J raised to the power half. Okay, or I can write it as root J. Okay, plus minus 4 root J is J power half. Okay, now dear, W square has actually two values. Okay, 4 J power half minus 4 J power half. So what is going to be W? Take the under root, further under root. Take the further under root to under root of 4 plus minus 2. Okay, J power half, right? And minus 4 under root of minus 1 is the imaginary number. Okay, the J will come. So under root of minus 4 will be plus minus 2J, right? Into J power half raised to the power half. Under root liya na. So what is actually W? Plus minus 2, J power half, J power 1 by 4. And this is plus minus 2. This is also J power 1 by 4 but multiplied by J. So J power total 5 by 4 because the powers will get added. Now what is J? The options are clearly in the Euler form. The options are clearly in the Euler form. So if I write down J, how do you write down J in the Euler form? E power J pi by 2, right? So that means W, which is already written as plus minus 2 J power 1 by 4 plus minus 2 J raised to the power 5 by 4. It is going to be plus or minus 2 E raised to the power J pi by 2 power 1 by 4 plus minus 2 E power J pi by 2 raised to the power 5 by 4. So what is the W? It is plus minus 2 E power J pi by 2 into pi by 4. So will be pi by 8. Okay, what I will do now? Okay, what I will do now? You will do one more thing. Okay, to write down everything in the Euler form. Okay, there are two solutions with plus and minus. Use minus 1 is equal to E power J pi. Can I use? Because E power J pi is cos pi minus J sin pi. It will be minus 1 actually. Euler's identity. Euler's identity, right? So if I use this, so W, see first is what? Plus 2 E power J pi by 8, right? Second, minus 2, but I will write down 2 and minus 1 will be E power J pi. Then further multiplied by E power J pi by 4. Pi by 8, sorry. Okay, third, plus 2, ये J तो eliminate हो गया था ना, sorry, this is only plus minus 2. Okay, then E raised to the power J pi by 2 into 5 by 4, so 5 pi by 8. And last one, let's not write minus 2, let us write down 2. Then minus 1 is E power J pi. Okay, then further multiplied by E power J 5 pi by 8. That is what it is. That is what it is. Okay, now if you have a look into them, I'll write down the list here. We have 2 E power J pi by 8, a complete derivation I have given. Okay, then pi plus pi by 8, okay, will be 9 pi by 8. So 2 E power J 9 pi by 8, right? Third one will be 2 E power J 5 pi by 8, and last one is pi plus 5 pi by 8 will become 13 pi by 8 to E power J 13 pi by 8. Okay. So which of them cannot be? It is option number A, right? We have pi by 8, we have 9 pi by 8, we have 5 pi by 8, next is 13 pi by 8, but anyways 2 pi by 8, that is pi by 4 cannot be root. Okay, cannot be the root. Okay. Next one, moving ahead to the next question, that is number 51, based on contour integral for 1 mark. So this time, in ECE 2 marker question I will move. They are relatively simple. Some 1 marker question are those which usually comes to 2 marker also, like in many of the previous year you will find such a question for 2 mark, but this time they have put it for 1 mark. But although it is easy only, it is very easy only, the value of the contour integral z plus 2 upon z square plus 2z plus 2, where the contour is given to you. Okay, z plus 1 minus 3 by 2j mod is equal to 1. Okay, right. So what is the function? Please note here, what is the function to be integrated? It is z plus 2 is divided by z square plus 2z plus 2. And what are the poles of this function? The poles I'll just try to equate the denominator to 0. Z square plus 2z plus 2 equal to 0, and z will be quadratic equation minus 2 plus minus root over b square, right, minus 4ac divided by 2a. So z is equal to minus 1 plus minus under root of 2j divided by 2, so under root of, only I am left with j. Okay. So minus 1 plus minus j, these are the two poles. Now let us talk about this given contour. What is the given contour? The given contour is modulus of z plus 1 minus j minus 3 by 2j, one the same thing, whole modulus equal to 1, and we can also write it as modulus of z minus, if I take minus common, it will be minus 1 plus 3 by 2j equal to 1, and this is of the form modulus of z minus z naught equal to r. Okay, this is the general equation of circle in the complex where z naught is known as the center and r is known as the radius. R is known as the radius. Okay, so if I draw this particular circle here in front of you, approximately, if I try to draw this, just a moment, hai na? So how much it is? What is the center? Center will be minus 1 plus 3 by 2j, right? X coordinate, the real part minus 1 and imaginary part is 3 by 2. This is the center, and radius will be 1. So it is going to pass through this 0.5 and 1.5. See, this is 1. Let's say this is 2, and it's going to pass from here, right? So approximately this is what is the circle that can be traced. Okay. Now out of this I have the two poles minus 1 plus j and minus 1 minus j. So guys, where is the minus 1 plus j? Right, this is going to be minus 1 plus 1. So approximately this is the 1 and minus 1 minus 1. वो third quadrant में जाएगा. This is minus 1 minus j, this is minus 1 plus j. This particular pole is inside and there is one particular pole which is outside. Now as per the Cauchy residue theorem, why we need this inside outside? Because as per the Cauchy residue theorem, right, as per the Cauchy residue theorem, integral fz over fz dz over any closed curve C is equal to 2 pi j into summation of residues. But which residues? The residues which are inside C. The residues which are inside the closed curve C. Inside the closed curve C. Okay. So here only one pole is inside the closed curve, so only that particular residue is to be calculated. So this is going to become 2 pi j, right, into residue of the pole. Which pole? Minus 1 plus j. Residue of the pole minus 1 plus j. And the formula, okay, for residue here, okay, the formula for residue will be limit z tending to a, because it is a simple pole appearing only once, it is not a repeated pole. Limit z tending to a, right, z minus a into fz. And what is the fz function? Fz function is z plus 2 upon z square plus 2z plus 2. Don't write like this, write down in the form of factors. It has two roots. Okay, write down z minus a, z minus b form. So you can write it as z minus 1 plus j, and second one z minus 1 minus j. Okay, so these two terms will be clearly cancelled out. This is cancelled here. Okay, and then you are going to substitute. Then you are going to substitute the value. ये हो गया 2 pi j. Substitute z equal to minus 1 plus j. So minus 1 plus j plus 2, z plus 2 divided by minus 1 plus j. Okay, then minus become plus 1, then plus j. So total it is 2 pi j. Numerator becomes 1 plus j. Denominator is minus 1 plus 1 cancelled. Denominator is 2j. 2j got cancelled. My final answer is pi into 1 plus j. My final answer is pi into 1 plus j. Pi into 1 plus j. That is option number B. Option number B. Pi into 1 plus j is the final answer. Okay guys, moving ahead to the next question here. That is, yes, again a good conceptual question, 1 marker from eigenvalue eigenvector set. Let the sets of the eigenvalues and eigenvectors of the matrix B be lambda k, where k is 1 to n, because yeah, if it is an n cross n matrix, it will have n eigenvalues. So the n eigenvalues are lambda 1, lambda 2, etc. and vk. Okay, again where k is 1 to n. Okay, respectively. Okay, so पहले B matrix की बात कर लेते. With respect to matrix B, eigenvalue is lambda k and eigenvector is vk. So as per the basic eigenvalue eigenvector concept, we can say that if v is a eigenvector or vk is a eigenvector, right, when you multiply b into vk, it should be proportional to vk, and the proportionality constant is lambda x. Like we write down the equation, lambda is the eigenvalue of the matrix A with the eigenvector x. So we write down what? We write down Ax equal to lambda x. Similarly here, V is the eigenvector, lambda is the eigenvalue. So BV is equal to lambda V. The matrix involved is B. BV equal to lambda V. So BVK equal to lambda K VK. This is what we know. Okay, now let's move forward. Okay. For an invertible matrix P, the sets of eigenvalues and eigenvectors of the matrix A, where B is P inverse AP, diagonalization process a related question, but you can solve it directly. Okay, where B is P inverse AP respectively are. What are the eigenvalues and eigenvectors of A, where B is P inverse AP? So what I will do is I will substitute the value of B. You will get the concept very clearly. So P inverse AP into Vk is equal to lambda K into Vk. Correct? Chalo. Multiply by P on both the sides. So if you multiply P here, P inverse will get cancelled. You will be left with APVK, right, is equal to, now lambda is a scalar number. Lambda is what? Eigenvalue. It's a scalar value. Okay. So you can write that clearly outside. Okay. And then P multiplied. Pre-multiplied hai. Okay. So PVK. Okay. Now guys, for a moment, let's assume that PVK is equal to something like X. Okay, so what is the equation now? If PVK is X, you have AX equal to lambda X. You have AX equal to lambda X, lambda KX. That clearly means what is the eigenvalue? What is the eigenvalue of the A matrix? AX equal to lambda X, eigenvalue is lambda and X is the eigenvector, because when you multiply A with X, the result is proportional to X. So X is the eigenvector. What is X? PVK. So what is the eigenvector? Eigenvector is PVK and eigenvalues are directly lambda k, not lambda k into something, right? So eigenvalues of A matrix are lambda k and eigenvectors are PVK. Eigenvectors are PVK. Okay. Chalo, done. So that is the next question. Okay. Now we have the 2-mark question. What is the value of the line integral? Simple one only. What is the value of the line integral P to Q? Okay, along the straight line joining the points 1, 1, 2 and 2, 3, 1. Let's do it up, and you can do it up very simply because of the fact that okay, you can apply the exact differentiation concept here. Okay, how? देखो z square dx and 2xz dz इसको combine करेंगे सबसे पहले, right? So I can write down the integral as integral p to q z square dx plus 2xz. Okay, 2xz. Now what is 2xz? Okay, dz. Write down x separately and 2z is the differentiation of z square. 2z, अच्छा इसको एक बार पूरा लिख लेते हैं. Okay, this is 2xz dz, right? Plus one more term, 3y square dy. This is what I have. Now look into the first. The derivative is only of x, z square is fixed. But in the second, dz के साथ 2z भी है. That means it is the differentiation of z square. But when you have the differentiation of z square, x is, sorry, not this, x is fixed. Okay, so product rule is being applied here. Okay, किसका product? The product of z square into x. Now, everybody tell me once again, if z square is constant, first function constant, differentiation of x, perfect. If second function x is constant, differentiation of z square, which is 2z dz. Clear? So, it is totally justified. What about the next term? 3y square with dy. So 3y square is the differentiation of y cube. Very simply we can judge. So the next term is the differentiation of the y cube. Correct. Now differentiation is a linear operator. So you can take it common. So you have z square x plus y cube, and differentiation and integral will cancel each other. They will cancel each other. So your answer will be, x z square x z square plus y cube. Only you have to substitute the lower and the upper limit. Only you have to substitute the lower and upper limit. There is no need of this straight line. along the straight line. Now, there is no need of this straight line. Why? Because exact differentiation is applied. When is the exact differentiation applied, guys? Try to recall, you must have studied. When is the exact differentiation approach applied? It is applied when the curl of the function is 0. So, of course, when you take the vector function separately and try to calculate curl, 110% blindly I am telling curl will be 0. Vector would be conservative and line integral will be independent of the path. That is why there is no use of the straight line. That is why there is no use of the straight line. Okay. So, what is the point P and Q? Let us substitute actually and complete the question. P is 1, 1, 2 and Q is equal to 2, 3, 1. Okay, so substituting the upper limit first, 2 into 1 plus 3 cube 27 minus lower limit, so 1 into 2 square, that is 4 plus 1. Okay, this is 29 minus of 5, answer is 24. Final answer is 24. Correct. That's it. Now, if you want, you can calculate the equation of line from the given 2 points and substitute here. You can solve directly also without this exact differentiation. But trust me, that is going to take a lot of time as compared to this method. You can try it out by calculating the equation of line. Next question here, 2 marks. Again, this is a very simple question. The 2 mark questions I found less time consuming. Okay. Now, let X be a n cross 1 real column vector with the length root over X transpose X. What is the trace of the matrix X, X transpose? Okay. What is the trace of the matrix? What is X? X it is a n cross 1 real column vector. So, X is something like, it is having the elements x1, x2, etc. up to the xn. That is what is a n cross 1 real column vector. All elements are real. Okay. And its length, we all know, see, even if they don't mention length root over X transpose X, you know what is L. For formality they have mentioned, but what is the length of the vector? You always directly know that it is given by square root of x1 square plus x2 square, etc. up to xn square, as we have used also in one of the previous questions. Now, what is the trace of the matrix X, X transpose? There is a matrix P which is X, X transpose, and X, let me write down here the vector given to you, column vector. When you take the transpose, it becomes the row vector x1 to xn. Row vector x1 to xn. Now, when you multiply, what is that you are going to get? First row, first column, x1 square. Then first row, second column, x1, x2. Similarly, next will be x1, x3, etc. up to x1 into xn. Next आ जाएंगे x2, x1. Next is x2, x2, तो x2 square. Next is x2 into x3 up to x2, xn. Right. Similarly, if we keep going, the last will be xn into x1, xn into x2 up to xn multiplied by xn. So that will be xn square. This is going to be a n cross n matrix. Okay. So what is the trace of this matrix, dear? What is the trace of the matrix P? Trace is known as the sum of the diagonal elements. So that is x1 square plus x2 square plus xn square, and that is nothing but the square of the length. That can be written as L square. Very simple. That can be written as L square, option number A. That can be written as what? That can be written as L square. Moving ahead to the next question here. Okay. The value of the integral xy dx dy over the region R given in the figure is. Okay. Now, देखो. Let's take this figure once again. You may take vertical strip or horizontal strip. I'll tell you what to prefer here. Okay. If I take vertical strip, okay, my limit will be minus x to x plus 2. Okay, for the negative value of x, and for the positive value of x, it will be x minus x plus 2. But guys, if I take horizontal strip, now please look into the fact that this picture is symmetric about y-axis. It is an even symmetric picture, right? It is not symmetric about x-axis, but at least it is symmetric about the y-axis. Okay, about the y-axis, this portion left and right is same. That is symmetric about y-axis. Okay, so whenever you try to take the horizontal strip, the function of y that will come will be symmetric function. See, x plus 2 minus x plus 2, only plus minus difference of x. Similarly, the value of the strip on this particular portion, okay, क्योंकि इसको पहले आपको दो पार्ट में ब्रेक करना पड़ेगा. On the lower side, it is minus x2 plus x, and symmetric limits will be more easier for to deal with. Okay, so the limits will be simpler. Now, what is this point actually? What is the value of y at which that breakage has to be done? At which that breakage has to be done. So, what is this point? This is the point when the line minus x plus 2 coincides with the line of x. Okay, coincides with the line of x. So, when you simplify, you are getting x equal to 1, right? If x is equal to 1, so y is also equal to 1. Y is equal to x, which is 1. Similarly, on this side, because of symmetry, you can say that if x equal to 1 on right side, you can calculate again, but you can use symmetry, na? That is the beauty. You can again equate d2, you'll get x equal to minus 1, but I can write down directly x is minus 1, y remains to be same. Height is same, na? Okay. Chalo, done hai. Right, so this is what are the limits. So, what is the integral given to me? Now, let me start solving that integral. Integral xy, right, integral over the region R xy, right, dx dy. Now, मैंने किसका limit लिया है? Right, I have taken the horizontal strip means limit of x, right, limit of x. So, x is equal to minus y, ध्यान देना, right, first let me write down, it is xy dx dy. Now, that I am breaking it, please say, that I am breaking it as integral first x is equal to minus y से plus y. Look into the first case, x is minus y to x equal to plus y. Y is minus x, so x is minus y, understood? Okay, but this particular strip has to be slided from y equal to 0 up to y equal to 1. So, limit of y here, limit of y has to be from 0 to 1, xy, yeah, order of integration is correct. First, we are integrating with x because the limit of x is dependent on y. Plus, this is only the integration from y equal to 0 to 1. But when you take y equal to 1 to 2, that is the upper half of the picture, this half of the picture, what is going to be the limit for x? X will be y minus 2. Please take a note, x will be y minus 2 up to यहाँ से x निकालोगे कितना आएगा? X will be 2 minus y. So let me write it like this. ऊपर कितना आया? 2 minus y, and bottom it was, I am correct, bottom it was y minus 2, correct. So they are again just differing in sign. Okay, y minus 2 minus of y minus 2. You can treat it like this as well. What is this limit? This is minus of y minus 2. ठीक है? चलिए, now xy dx dy. That is why the problem is now going to become simple, because first you will integrate with x. The integration of x is x square by 2, okay, and dy will be left. But what is the limit of x you are going to put? Symmetric limit minus y to y. Symmetric limit y तो चलो 0 से 1 हो जाएगा. Similarly, next picture, y is okay 1 से लेके 2. Y is 1 से 2, but integral of x is x square by 2, right? If lower limit is y minus 2, upper limit is minus of y minus 2. Minus of y minus 2. Now think, what is your answer? Arey Baba, what is your answer? X square by 2. Whether it is, when you put upper limit y square, even if you put lower limit, minus y ka square is eventually y square, it is 0. Similarly, second one, it is again like minus a and a. Okay, when you put inside x square, both will be same. So answer for both the parts is 0. Answer for both the parts is 0, and the total answer is also 0. That is why that horizontal strip is easier to simplify. Okay, clear? That's it. The answer is 0. It was a NAT question for 2 marks. This is a good question. This is a good deserving 2 mark question. Okay, answer is 0. Okay, so these were the mathematics question. As I told you, strictly if I talk about mathematics, we have seen 11 marks of question. One question can be adjusted with communication. That is why mathematics you are seeing 11 marks. 5 questions we have seen for 1 marker, and 3 questions you have seen for 2 markers. That is making 3 plus 6, 11 marks. And now gradually let me also move towards, right, the general aptitude. Okay, general aptitude, I'll just discuss the quantitative and logical reasoning part, not the verbal portion. For verbal, no need to have a detailed discussion. I'll just give you the answer key. Okay, so there are only 3 verbal questions, 2 of 1 marker and 1 of 2 marker. 4 mark verbal, rest is total quantitative and spatial aptitude and analytical aptitude, that is logical reasoning. Okay, so the answer for this question is going to be C, conscience. Okay, next, courts is to judiciary. as parliaments is to legislature, iska answer A ho jayega. Okay, next one, yeah, let's start discussing this. This one is actually very simple. This one is actually very simple. What is the smallest number with distinct digits whose digits add up to 5? Distinct digits. Distinct digits. This is definitely wrong. 9999 repeated digits. Even if you see this, distinct digits. Okay, so these two are eliminated. Okay, now there are two options with distinct digits, right? 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 7 8 6 9. Both of them, summation 1 to 9 is 45. You can tally that also. The digits will add to 45. But which is the smallest one? Okay, 1 2 3 4 5 6. 1 2 3 4 5 7. Here 7 comes first. यहाँ पे distinguish होगा, right? Here 7 comes first. Up to 1 2 3 4 5 it is same. Here 6 come first. So 6 is lower. So option number C. 6 is lower. So option number C is going to be correct. Okay. Next one. In a class of 100 students, a Venn diagram regular question. In a class of 100 students, there are 30 students who neither like romantic movies nor comedy movies. Okay. Okay. Then the number of students who like romantic movie is twice the number of students who like comedy movies. And the number of students who like both romantic. So how many movies? Only two categories, romantic and comedy movies. And there is a class of 100 students. Okay. Let me make this Venn diagram first of all. Okay. Let us first take the sample space. Okay, sample space where you have total of 100 students in a class of 100 students, and then there are two categories to be included in this. One is for romantic and one is for comedy. In a class of 100, there are 30 students who neither like romantic nor comedy. So there will be the 30 students who fit totally outside. Okay, the number of students who like romantic is double the number of students who like comedy. The number of students who like both, okay, both romantic and comedy, that means this common portion. Okay, that number is 20. Okay, so here 20 will come up. I have written here 20. 20 students are falling here. How many students in the class like romantic movie? Okay, so 20 like both romantic and comedy. Let's say X is the number of students who only like romantic. We all know in the Venn diagram, this particular portion up to this point. This portion, this is the students only liking romantic. This is the portion liking romantic but as well as comedy. Okay, then the next category, this is the portion which is this number of students only liking the comedy. Okay, that is why. Let us say that is why. Okay, clearly mentioned. Now, what is the total number of students liking romantic? That becomes X plus 20. Okay, and what is the total number of students liking comedy? That becomes Y plus 20. But then there is one more data given. Acha, the total of all is 100. Okay, total is 100 students. Now, total mein kya aa jayega? Okay, total means one has 30 portion, then plus X, plus these 20 students, plus the Y students is 100. So, I have one equation between X plus Y, 30 plus 20, 50. So, remaining is 50. So, X plus Y is 50. X plus Y is 50. That is one of the equation I have. The X plus Y is equal to the 50. Moving ahead to the next. Okay, what is the next? The number of students who like romantic is twice the number of comedy, right? Romantic is twice the number of comedy. Romantic is X plus 20. Comedy is Y plus 20. Okay, so X plus 20 is 2Y plus 40. X plus 20 is equal to 2Y. Now, Y can be written as 50 minus X. Y is 50 minus X. 40. So, I have X plus 20 is equal to 100 minus 2X plus 40. 2X on the left side, total 3X. 100, 140 minus 20, 120. So, X is equal to 40. Right. So, how many students like romantic? The romantic answer is X plus 20 and X is 40. So, total answer is 60. Total answer is equal to the option number C, that is 60. 60. Simpler one only. I am explaining you in detail, that is why it takes time. Otherwise, when you try to solve it, yeah, when even I try to solve on my own skills, very few seconds you can get the answer. Okay. Venn diagram. Next, how many rectangles are present? A very simple observation question it is. How many rectangles are present in the given figure? Okay. Now, it's a very simple counting spatial aptitude question, you can call it as. Okay. So, if you talk about the number of rectangles present, see, one is the bigger one. One is this bigger one. Okay. Definitely one is the bigger one, and one is the interior bigger one. इसकी बात करेंगे, ठीक है. So these itself are 2, right? These itself are 2. This is 1 and this is 1. So यहाँ से आ गया total 2, right? This is total 2. Now it is very easy to identify. Now it is easy to identify if you have got 2. Okay, if this is 2, then this is 1, 1, 1, 1. Okay, so 2 from here, 4 from here. Anything else? Now, anything else I can show you just like this. In this particular tilted rectangle, that was my rectangle number 2. Okay, there are 2 separations, one horizontal, one vertical. 4 rectangles I have already shown you there. Okay, now count like this. Okay, this is 1. Okay, rectangle and not square. We need rectangle. So this is 1, then this is 2, right? Then this is 3, and then this is 4, right? So how many? 4 more from here, right? How many? 4 more from here. Total answer 10. You count any other thing, there will not be any other rectangle that will be found. It is 10. Final answer is option number C. Okay. It's a random picture given. You need to find the rectangles. Okay. There are some questions which you can solve by the concept of permutation and combination as well. Okay, especially by the combination, by selection, but that is rectangles within rectangles or rectangles within square, square within rectangle grids, etc. But this is some random figure. It has, inclined lines as well and all those things. So, but the easy observation, 10 is the number. Okay, these were 5 1-marker question of general aptitude, and now we have a 2-marker question. This is a question with it's a category of syllogism. The only difference is in the past years you have seen syllogism questions in direct manner, given 2 statements and given some conclusions. Based on the statements, which of the conclusion you can logically infer directly, right? All cats are buses, or buses are tractors, something like that. Some rubbish statements they will make, which you have to assume to be true and decide the conclusion. It is similar question only, but rather than giving direct, they have given in the form of passage. It is not a passage verbal question. There is one question of verbal in passage also. I'll show you that. I'll tell you the answer for that. But this is not verbal. It is a passage based question based on logical conclusion. Which one of the following options can be logically inferred? You see that end question also. So let's read now. Okay. Forest land. Okay. Let me, one of the option is hidden here. So let me uplift this first and then let's start solving here. Forest land is a planet inhabited by different kinds of creatures. Okay. Among other creatures, it is populated by animals, all of whom are ferocious. It is populated by animals, all of whom are ferocious. So I can say that all animals are ferocious. I can say that all animals are ferocious. If it was a regular syllogism question, like past years, they can give the statement, all animals are ferocious. Okay. So I'll start making the Venn diagram roughly. Okay. So I have some creatures which are ferocious. Let me call it as F. Okay. And definitely animals are ferocious. All animals are ferocious. Okay. There are also creatures that have claws and some do not have. Okay. So there are creatures with claws and without claws. Okay. All the creatures that have claws are ferocious. Again, something is coming under ferocious. All the creatures that have claws are ferocious. Okay. So let us say these are the creatures with claws. Okay. These are the creatures with claws. Okay. Let's call it a CC, creature with claws. In short, I am explaining you. They are ferocious. Based on only on the information provided above, none of your knowledge, none of extra general knowledge, based only on the above information, which of them can be logically concluded. Very easy options. All creatures with claws are animals. All creatures with claws are animals. Can we conclude that? All creatures with claws are ferocious. Animals are also ferocious. But see, it is possible that these 2 circles that I have drawn may be overlapping, may be totally inside, but that is only a possibility. Can you confirm with certainty? There is one more important word, right? With certainty. 100 even if they don't mention the certainty, you should assume that conclusion means one which is 100% true. 100% true. Okay. So no, this is just maybe. Some creatures with claws are non-ferocious. No. All creatures that have claws are ferocious. Some ki baat hi nahi aa rahi. Kuch nahi, sare. All creatures with claws are ferocious. So this is also wrong. Okay. Some non-ferocious creatures have claws. Some non-ferocious creatures have claws. Ultimately, it's a creature. And if a creature has claws, it cannot be non-ferocious. It cannot be non-ferocious. It has to be ferocious. Right. So this is wrong. Okay. Some ferocious creatures are creatures with claws. some ferocious, so these are ferocious creatures. Okay. There are so many ferocious creatures, so many, but out of that so many, there are some of them. These are some, kuch aise hain, which are the creatures with claws. Some ferocious creatures are the creatures with claws. This is absolutely correct. Answer is D, which can be inferred. Which can be inferred. The approach is the same that we use to solve syllogism question. It is syllogism only, but given in the form of passage. Okay, the two important words that helped you in solve the question is, there are animals, all of whom are ferocious, okay, and all the creatures that have claws are also ferocious. Okay. Okay. Animals are ferocious and creatures with claws are ferocious. These are the two statements like that which is given to you. Okay. Chalo. Moving ahead to the next. Which one of the following option? It's a 2-mark question, but it can be a very simple bonus. It is a bonus 2-mark question because if you apply your idea, see, if you try to solve it by the graphical approach, and guys, I told you, looking into last year patterns as well, like when IIT Kanpur lastly conducted in 2015, there were questions based on functions and graph and aptitude. And I told the students before the exam also, because 2023 again being conducted by IIT Kanpur, we can expect some questions based on graphs or functional knowledge. And it was there in many of the branches, not only electronics. Okay. But it is not that question where you have to find out the equation of the curve. It's going to take time. No. If you just look into one concept, that the given function is even symmetric. If you use small points, 2 marks easily in your graph. This is even symmetric, and even symmetric should always satisfy f of minus x is equal to f of x, and the only option that is even symmetric, it has x square as well as modulus of x. It is option number A. That is even symmetric, because in B, x, it will be an odd symmetric part. D, x again odd symmetric part. C, mod x is there, but 2 power minus x, which is not even nor odd, nothing. Okay. So we all know that modulus is a even symmetric, x square is even symmetric. Or if you want, you can try f of minus x ka square 2 power minus mod x, minus x ka square again x square, minus of mod x. There is no role of minus inside mod, so minus of mod x is again mod x. You will get exactly fx. That is why A is the even symmetric option. Option number. Anyways, MCQ question, only 1 mark can be correct. You can move ahead to the next one. Okay. Yeah, this is a passage based question which is from verbal, and as I told you, verbal I am not discussing. I'll just give you the answer key for verbal. Please take the answer for this. It's going to be B. You just read it up and see your options accordingly. Let's move ahead to the next question, that is number 64. Yeah, this is a decent question. Okay, you have to understand what is happening here. Good practical question, in fact, we can say. Out of 1,000 individuals in a town, 100 unidentified individuals are COVID positive. There are 100 individuals which are COVID positive out of 1,000, but the problem is they are unidentified. Okay. Due to lack of adequate COVID testing kits, the health authorities of the town devised a strategy to identify these COVID positive. We don't have that many COVID testing kits. There are 1,000 individuals and I don't have 1,000 testing kits. Okay. And I don't know who are COVID positive because they are unidentified, right? Okay. Now, what is the strategy? Okay. The strategy has been devised by the authorities, health authorities. Collect saliva samples from all 1,000 individuals. Samples we can collect from all. No? To test them, the kit is not available, but saliva sample can be collected. To collect from all and randomly group them into set of 5. Randomly group them into set of 5. Randomly, at random. कोई भी 5 को एक group बना दिया. Mix the sample within each set and test the mixed sample for COVID. Test the mixed sample for COVID. To mix the sample within each set and test the mixed sample for COVID. So all 5 I mixed. I don't know whether they are all 5 positive or all 5 negative, or maybe 1 or 2 positive in them. But I mix it up and I test for COVID. If the test done gives a negative result. Now see, I have mixed 5 samples. Even if one of them was COVID positive, the sample would have given positive result. Okay, so if the test done for the sample gives a negative result, that simply means all 5 are COVID negative. Declare all 5 individuals to be COVID negative very clearly. Okay, but if the test done gives a positive result, then at least 1 out of 5 individuals, is a COVID positive. I'm not telling only 1, maybe 1, yeah, maybe 2 of them, yeah, maybe all 5 of them. But some of maybe 1 or 2 or 3 or 4 or 5, something is COVID positive. At least one is COVID positive. Okay. So now what to be done? Okay. So if the test done given a positive result, then all 5 individuals are separately tested. But at least if that sample of 5 has given negative, so all those 5 need not to be retested again. Okay. This is the strategy. Given this strategy, no more than dash testing kits will be required to identify all 100 COVID positive, irrespective of how they are grouped, because they were grouped randomly. Okay. So number 1, they are devised and groups into sets of 5. Okay. There are 1000 people. They are divided by 5 and we have 200 groups, and first of all we need for each group 1 kit. So at least 200 kits are needed. Okay. Right. Now, out of this 200 kits, how many will be positive? Think. We don't know exactly, but how many can be maximum? How many maximum kits can be positive? How many maximum? How many individuals are COVID positive? 100. What is the worst case scenario that? What is the worst case scenario is that all 100 COVID positive members, because the mixing was done randomly, worst case possibility, unluckily, that all 100 COVID positive were only one in a particular group, right? Matlab there was no group containing 2 COVID positive and 3 COVID positive. Okay. All 100 COVID positives, okay, were alone, okay, in a particular group of 5. Okay. That means if I want to talk about worst case, out of this 200, 100, okay, 100 groups turn up to be positive. And because 100 groups are positive, whenever a group is positive, you have to test all 5 samples. Okay. So now you have to test what? Now you have to test these 100 group, and every group containing 5 people. So now you have to test 100 into 5 persons. So you need 500 kits. Okay. Total maximum of 700, 200 initially and 500 at the last. This is maximum. This is maximum. It may be possible that, least case kya ho sakta hai? What is the least case? Best case. This is the worst case. Now question is done, but just I am explaining you what could be the best case, right? Best case is, there are 100 COVID positive we know, 100 divided by 5. The best case could be, luckiest case could be, to save the kids, that all COVID positive groups luckily were combined in the groups. Matlab, suppose I pick one group, all 5 positive. Suppose I pick next group, all 5 positive. So how many? 20 groups. Okay, 20 groups means 20 into 5 kits. 20 into 5 kits. Total 20 into 500, 100 plus 200, 300 kits. Okay, this is just for extra. So even in the best case, you need 300 kits, that is minima. Otherwise, maximum is 700. But the strategy is to think about the maximum number, so that we come to know, okay, at least for this worst case, we have the kits or not, given this strategy. Okay, so no more than 700 kits. Option number A will be required. Okay, done. The next and the last question of general aptitude: a 100 centimeter cross 32 centimeter rectangular sheet is folded 5 times. Each time the sheet is folded, the long edge aligns with its opposite edge. The long edge aligns with its opposite edge. This is 100, this is 32. Each time it is folded, the top edge, this is the long edge 100, will be colliding with the aligning with the opposite edge. So this time, this is how it is folded, and when it is folded for the first time, you get a crease here, right? You get a crease. Now when you have folded it, okay, you have got a paper with 2 sheets, you can say. Okay, you have a paper with 2 sheets. It is folded how many times? 5 times. So when you fold it for the first time, you get how many creases? You get only 1 crease actually. But when you fold it for the second time, you have 2 pieces of paper, and when you fold, both are folded, so 2 creases. Each paper will give you 1 crease. So next when you fold, you'll get 2 creases. Now when you have folded 2 times, 2 2s are 4. How many papers are there? 4. So sorry, I don't have any specific large piece of paper here. Let me see. Then it would be easier for me to tell it to you. Just a moment, guys. Yes, sorry. Yeah, I have got some random page here. No issue. So see, the point is, when I fold it for the first time, I got one crease. Is it clear? I've got this one crease. Okay. But now when I fold it for the first time, it is like two pieces of paper, two sheets. So when you fold it for the second time, each of the paper is getting folded, na? Each of the paper is getting folded, and every paper will create a crease. So how many creases? Two. Okay. Now after doing the second time, how many pieces of paper? 1, 2, 3, 4. 4 pieces of paper will be there, right? Okay. Acha, till now how many creases? 3 creases, everybody. 1 plus 2. Okay. Now when you fold it again, these are 4 pieces of paper. If you look into this, these are 2. I'll show it from this side. These are 2, these are 2. So when you're going to fold it again, how many creases will be added? Every paper will create its own crease. Okay. And next would be 4 creases. Next would be 4 creases, right? So total it should be 7 by this time. You can pause the video and count, okay? You can pause the video and count. Similarly, when you fold it for the next time, 8 more creases. So 1 fold, 2 fold, 3 fold, 4 fold, and it is to be folded 5 times. So up to plus 16. Okay, so this is 24, 28, 30 and 1, 31. The answer is 31. A question which is in a sense spatial aptitude question. Clear? Right. Okay, so this was the last and the 65th question of the GATE 2023 Electronics and Communication paper. I hope you have understood this, and I hope you have liked and enjoyed the complete video. Every faculty putting their effort to explain you brilliantly the concepts and the detailed solutions of all the questions. Right? Do not forget to subscribe the BYJU'S Exam Prep channel in case you are still not subscribed, and do mention in the comment if you have any doubts. The faculties, the team will be active to reply to your query, and also do mention in the comment how you liked the video, how you liked the effort, and if you really like this, do not forget to hit the like button and subscribe once again. If you are not subscribed, subscribe so that you keep getting good content for GATE and engineering services preparation. This is Rakesh Talreja finally signing off. Bye bye. Thank you. Stay safe and take care of yourself.